it's my pleasure to announce Guru, who's going to be talking about energy demand with machine learning. Welcome.
Yeah. Good morning, everyone. I'm Guru Swamy Revana, working as Associate Professor in the Department of Electrical and Electronics Engineering at Hyderabad, which is in India. So my topic is about energy demand prediction with machine learning. So this topic is going to be a unique topic in this summit because all the people will be talking about AI in different techniques or in computer engineering. But here I'm going to talk about how do we predict energy demand for any building by using open source technologies. So now coming to my objectives, all of you can see because we are staying in a very good building, and you know the energy consumption of the building for the ACs or for the lighting or for the fans are going to cost, because energy is not for free. We are using energy from different sources, mostly from thermal power energy or hydel power energy. So we are using natural resources, so we should not use them excessively. So how can we use them in an optimized way is the main objective of my presentation. So basically, how do I predict energy demand? So I am going to predict energy demand for a month. For that, I am going to use weather data for 3 years, and also I am going to use energy consumption of the building for the 3 years. And later, I am going to discuss you about what is the energy cost per a month actually. Now, what are the different libraries I use? So as I got the data, so I was for data analysis and manipulation, I was using pandas, and for support of large multi-dimensional array, I'm using NumPy, and for data visualization, I'm using matplot library, which is a pyplot one. So now what do I do? So the first one is I take the data. So here all of you can see I'm taking the building number 12 along with the time. Here you can see everyone. So I'm going to take, okay, it's not working. Yes. Okay. If you can see the data, so you can see from, I'm taking the data for one complete year. So you can see 26,303 rows with the 2 columns. The first column is all about the time. For every 1 hour, I'm taking the data, and I'm taking what is the electricity consumption of the building for every 1 year, starting from the January to the December of that particular year. Okay, for the 3 years, I have taken it 2016, 17, and 18. So from January to February, I have taken the data, and I got it in 2 columns. Now you know, so what do? I do the description of the data. When I do the description of the data, total number of data is going to come. The mean values, the standard deviation value, minimum value, what is 25% of the load, 50% of the load, 75%, and maximum value. So I describe the data, so to check out whether it is coming or not. So later I draw the box plot, so both in horizontal way and vertical way, so that I can find out whether it is where it is going to stand, where my minimum value, maximum value, 25%, 30% is going to stand. And I have observed that most of the values are lying between 20 to 30%, which is present in the block. After talking about the energy consumption, I talk about weather data. So in weather data, all of you can see I am talking with the time again for 3 years, starting from January to December for 2016, 2017, and 2018. For every 1 hour, I am taking the data. HH stands for the hours. T stands for temperature, U stands for relative humidity. After that, temperature, RH, and relative humidity. Q stands for weather conditions, DR stands for the wind direction, and FF stands for wind speed, FX stands for wind gust speed, and P stands for atmospheric pressure. Based on these 3 values, we are going to switch on and off our electricity things, switch on and use our electrical appliances accordingly. And basing on that, I correlated my values with electricity. So here is the correlated, or it is called as a heat map, where I correlated all the values of the weather, what all the temperature, humidity, pressure with respect to this graph, which is called as a heat graph. So you can see here, you can see the heat graph here where the blue stands for the cool temperature, and as it goes from blue it goes to the orange, and from orange it goes to the red. Red indicates that the temperature has increased. If you look at this graph actually, and we come to the last one, which is a mean one, so you can see the temperature correlates in a positive way, and later you also can see that humidity and precipitation. So both of them are negatively very high. So these are the values which we take, and they are also multi-collinear. So basing on this heat map, we finally conclude like the temperature plays a major role in the energy demand, because all of us know when the temperature increases, we switch on our ACs. That's a normal one, which is proved by the data, and also humidity also speaks, and also the precipitation matters when you go to coastal areas. So that's what, and there are also multi-collinear one, which is used for the predicting of the energy demand. Now after that I have plotted the values. You can see the red one starts for energy consumption, which is along with the temperature. So the temperature is in the blue line, and the humidity is in relative humidity, which is in the green one. Okay, so the red one stands for energy, blue one stands for temperature, and green one stands with humidity. You can see the humidity is negatively coefficient. So yes. So you can see here. Yeah. You can see here that temperature and energy consumption are red and green wire are together, whereas the green wire is exactly opposite. So we are taking for every month here, for every month actually for all the 3 years, and every week data. The dots in this graph represents the every week data we are going to correlate. So almost temperature and the energy consumption are together, whereas the green one is exactly opposite. Sometimes temperature, humidity and energy demand are together, which means that they are in the coastal areas, and again during the summer. So basing on that, we see that the energy demand is with the temperature with this plot, and energy consumptions varies with the seasons. From this graph we are also able to know about the different seasons which are occurring at that building. And all of you can see the negative linear correlation between the humidity, which is already explained. So whenever it is humid, we are going to switch on. And it is not just correlation with energy consumption, but also high negative correlation with the temperature. The humidity has negative correlation with the temperature. So this is how the graph has been drawn. And later, after getting all the data, we started working with machine level regression. We started, prediction. So in order to have the prediction, we worked with different literature surveys. So various forecasting surveys are used for this machine learning models. So after the testing and performance was done with the machine learning models on building energy management system we have done. So we have finally found that from the literature, there are two methods or two algorithms which can be used, which is support vector machine, and also random forest algorithm can be used. So we are going to see which one is the much better. So is it support vector machine algorithm, or random forest algorithm is going to work better in a way. So later after that, so I worked with a support vector algorithm, and you can see there are two colors in this graph. For your clear understanding, I can very simpler way say that there are two colors. So one is the original value and the other one is predicted value. So after using algorithm, so we have the original value from the data, and we also able to predict the data. So the orange one stands for the predicted value of the data, because my method is to predict the energy consumption in a building management system. So we are able to predict, and we are also able to see the original graph, and after that we were able to find out that the accuracy of this was only 86%. And later we went for RF method, random forest regression model method. So here we have two graphs again. One is a predicted one, the other one is the original one. So from this model we were able to get 91%. By adjusting few parameters in the coding, we were able to get 98% accuracy also. So after working with the database, after working with different ML algorithms, we find like random forest regression method is going to be a much better method, where the accuracy of the predicted value to the original value is 91%. And later, so allocate budget predictive model. So our main aim is how much budget we have to allocate for the building monthly. So till now I have spoken about 3 years data, which is calculated for every month. But here, but here what we are going to do is we are going to take it for every month actually. So here you can see we have from January 1st to January 31st, we have 12 columns for the weather, which we have taken. And later, we use the predictive model monthly. So we are using the time along with how much energy it has been calculated for every month. And later we are able to hourly forecast the kilowatt hour, the energy consumption unit is kilowatt hour. So we were able to forecast all the data of every month, every hour. So we are able to predict the data in such way. And after that we were able to plot the price, because kilowatt hour, if you can look at the x-axis, it is all about energy consumption kilowatt hour with respect to the time. And it is multiplied with a certain value so that we get the price, like, because every unit carries a price, every electrical unit carries a price. So we are getting an hourly price and we were able to get the predicted consumption. Both are together, that's why you are able to see the only crowd. Now after that we were able to use the predicted sum. So you can see this graph, what is the daily price versus hourly predicted consumption. So you can see the graph is almost equal. So this is daily predicted consumption and what is the actual use. So we were able to do that. And after finally we are keeping a threshold value. Suppose we keep a threshold value. Here I kept a threshold value of 160 kilowatt hour consumption. So if something goes above, there will be a warning sign which is given. So finally, what all the data which we obtained in the previous one, so we were able to do it in a data analytical way. So it is in a visual way. So we were able to analyze and we were able to provide the warning to the building, like you are crossing the limit which we have kept or allocated for the day, or the energy allocated for the day, or the budget which is allocated by that way in this visual consumption. So with that, I'll end my presentation. Thank you all of you. And I request all of you to conserve energy, because energy is not for free. It is all produced from the nature. And it is going to deplete if you are not going to use renewable energy sources. Thank you very much, all of you.
Thank you very much. Got time for maybe one question for Max, if anyone's got, oh, sorry. Gus. Max, come on up. Yes, next. Sorry. Yeah. Any questions? Hands up. I can't see. There you are. Get ready, Max.
Hello everyone, hello sir. I have a question for you.
Yeah.
How would your model react to climate change? Yeah.
Oh, you are talking about emission.
Yeah.
Yes. Basically, we didn't work on the emission. We were talking about building. So building doesn't have any emission. It has only consumption. Okay. Hope you understood my answer. So we are suppose we take this building and find out how much we are going to predict the energy consumption of this building.
I mean, the climate change affects the data of the input, right?
Okay.
So I want to know how your model reacts to that kind of data change.
Can you be a bit louder? I can't hear you.
Climate change applies to the data and changes like every single day. It affects the data input, and I want to know how your models would react to that change.
Okay.
How does the model change with climate change?
Oh, yes. We can predict the data because we are going to take the data of the previous value and we are going to, the model changes actually. Yes. It's an adaptive model which we have created.
Okay, thank you.
Yes, thank you very much. Thank you. Thank you, everyone.
Thank you. Where? Sorry. Hands up. I can't see.
Yes. Yes, thank you very much. Thank you. Can I come to you and answer the question because they are telling to end this? Yes, the next speaker is ready. I'll come back to you and I'll answer the question. Yes, thank you.
Yep. Thank you. Okay. Just a reminder, everyone, if you could turn your mobile phones on to silent, that'd be great. Okay. You ready, Max? Right. Now I'd like to introduce Max, talking about maximizing AI potential. Welcome.
I use this. Yeah, hello everybody. My name is Max. I'm the co-founder and CTO of Soji AI, and I'm here to talk about the pitfalls of taking your AI product, right, from demo to production. Things can go wrong, and how to put your users first. All right, I will go over roughly 4 points that I've learned over the past decade and related to various projects that I worked with, and the one I'm currently working on. First things first, I think many people have heard about using the recent advances of ChatGPT, of RAG, which is like AI-powered search, to build like tools that can answer questions, right, and help your users, building co-pilots. And I'm here to talk about what things can go wrong, right, once you go and take your product or your tech demo that you have, right, the thing that you build at a hackathon, once you take this out in the real world. First things first, I love RAG. It's so great to demo, and the experiences we had over and over again is once you build something and you take it out there, people come back with a lot of issues that you haven't foreseen. So let's talk about a few of them, right? First of all, you have the semantic search, which is you use the AI to create some kind of embedding, and you can find documents related to the question of the user, which works like magic, right? It's great. But as soon as people start uploading hundreds or thousands of files, it actually spits out the wrong document more often than not, especially once you have like conflicting information, once you have duplicate information with like slightly different context. This is where filtering and metadata stuff becomes vitally important. Intent detection is one other option, right, to change these kind of things. Let's say, right, you have your users, and I'm talking about like a very specific use case in a bit. The more you can narrow down which documents you're going to search and using the semantic search, the better results going to be. Right, so you need to figure this thing out. The guiding principle we use here, coming back, the recurring topic of this talk is going to be user-centric design, is what is important to the user, right? What do they care about? When they ask a question, they usually have a subset of the documents in mind they want to search through. It can be spreadsheets, right? It can be uploaded documents. So the more we use this as a guiding principle, the better the search usually gets, right? LLMs can help here a lot, but there's a huge trade-off. And I want to argue against using LLMs for everything, right? I mean, it works like magic. And with like the newspapers, if you read them, if you like use an LLM like 20 times, right, to perform multiple searches, to combine the results, the accuracy goes up and up and up. But at what cost, right? If it takes 5 minutes to get an answer, is maybe not as useful of a tool, I would argue. In some instances it might be, but not in everything. In organizations, right, you run into the issue of dirty data, dirty documents, drafts, people that are no longer there, references to documents that no longer exist, right? So the real world is really messy, and figuring that complexity out plus basic reg usually yields much better results than just trying to get one LLM prompt, right? You search for one prompt that just fixes everything. That usually doesn't work. So the question is now, how do we look at our system, right? So we take our system out to the world, and how do we get feedback that helps us make this product a bit better for users? I want to talk about the first example in this talk, right? Slide generation for consultancies. So we work with consultancies that uploads like thousands of documents, and their main core business is to create new presentations based on the existing ones. When they do so, they go through different phases, and every document that they upload, every presentation has like different sections, right? And every slide is of a different type. Maybe it's a roadmap, right? Maybe it's an introduction, maybe it's something else. So if users look for, hey, I want a team overview from like an automotive project that we had in the last 3 months, we can use all this information to filter on the metadata beforehand. But we need an AI model for that to detect what slide is what content, what slide has what information, to accurately filter those things. Especially with like recent and successful projects, right? We found like a huge benefit once we slightly bump up the search results of like recent documents within the last 3 months, because these tend to be the most relevant, right? As the lowest chance of these being outdated. And we're looking for silly things, right? Underscore version 1, version 2, version 3, right? This is how we all named our final PowerPoint presentations every single time. And just looking for like these suffixes and just looking for like the latest one really helps making the product more successful, right? There's also conflicting knowledge. There's tons of paper on how to resolve these things, but if you don't tackle them, sometimes RAG will just combine snippets from like different sources that say the opposite, and it gets very confusing after that, right? So you need to find a way to remedy out of this. So from prototype to production, I would argue using LLMs, you first need one thing, right? Guardrails. The first thing we talk to users about is error budget, right? If you're talking to a finance company or a fintech company, they will tell you, we want like 0% errors, right? We cannot live with like 2% error rate. That's way too high. We cannot make any mistakes, right? But if you make suggestions or you create dashboards or alerts, users can read these and decide if they want to interact with the information that they see, and suddenly your error budget is much, much higher, right? So LLMs are not great for math. They're not great for the fintech stuff that I told you about. So let's look into this a bit closer. We like LMQL, one of the open source libraries that can help you to basically streamline how the LLM works and like restrict the outputs you're going to get. So you can even tell it like, I only want like 120 words, I only want one of these 5 options as a result, and that way you know what you're going to get, right? And the LLM does not give you nonsensical outputs. But LLMs can also make it easier to bootstrap existing applications, right? I'm a huge fan of taking Hugging Face models, fine-tuning them for your use case. Let's say you have intent classification, right? So you're building a fintech product. Your users have like 5 types of questions that they ask, but you want to run different code, different prompts, different search results, different search filters based on these questions. If you identify which of these 5 types it is, it's much better. If you use LLMs for that, the accuracy is so-so, right? You get like 95% correct. So sometimes really frustrating for the users where they try to like reformat, rephrase the question that they just asked in the hopes that the AI really detects this well. So if you build a model that does this faster, more accurately, it's a lot better in the long term. Also, we have to talk about data drift and concept drift, right? So in the long term, what users talk about changes. Also, if you have multiple teams using your software or multiple companies using your software, right? They will use different lingo and different words, and your model is not prepared for that. So how do we make sure the quality of your AI increases over time? Brings me to the next point, data and model tracking. First of all, it's very important to, maybe if you start out with a tech demo, you don't think about this, but once you go into production, you want to record all the interactions with your tool, right? You want to know what was said, right? What did the RAG pipeline do? What are the search scores? What documents were used? What filters were used? So in the long term, you can improve your AI models, right? You can see what was the output, you build a new model, you compare it to the old one, you see which one fared better. MLflow, a huge shout out, is one of these tools you can use to collaborate with other people, upload your models, evaluation metrics, and also track usage. There's myriad other tools out there. But how do you know that a new model is actually better, right? So one example I like to use, I was working on like one small short text classification problem with like a small team. And turns out in the beginning, we just had like a Python server, right? That would classify incoming texts, right? Store the result in a database, and we would use this for like downstream applications. And it's great, but then we were figuring out like, oh, now all these new models are there on Hugging Face and LLMs are coming in, right? Which of these can we use? How do we A/B test them? How do we know which one's better? And so we managed to build an application that basically is like some running the models in parallel, but then saving all the answers, but only using some of them. We used AWS Lambda quite successfully to run very small models. And so people, the data scientists, could like bootstrap new models and run them in parallel in production without them affecting the outcome. Nice side effect is after a while we discovered if you combine multiple models in an ensemble, we could boost the accuracy basically for free, right? All I'm saying is if you don't run your models in production, the new model, right, you don't know if it's actually performing better in production. You know that it performs better in all the data you've seen until now, but you don't know what's going to come next, right? Same goes true for like outliers. Once you get data that is like very different from everything you've seen before, you do want to find a way to track this data and add it to your training set or discard it or have some error handling for that. So what I'm going to argue for is user-centric AI development. There's like a couple of papers that Google put out like roughly 5 years ago. They're still extremely relevant, where they argue that you don't want to surprise the user, you want to have them work with AI, and you don't want to dictate the outcomes on them, right? So you want to set the right expectations from the start. If you tell your user, my AI is 100% accurate, it's always a lie, right? It never works like this. So the more you can involve your user, the easier it is to create like a feedback cycle. And I think that's a really powerful takeaway from this talk, is once you have this feedback cycle, be it the intent classification in the beginning, right? The text classification, the search results, as long as the users can feedback, right? You have actionable data you can use to improve your AI models, your workflows. For example, in a simple search, right? Thumbs up, thumbs down helps great. So if people actually use that, you can use this to fine-tune your search. You can use a new model, you can use a new prompt, and you can compare this to all the thumbs up, thumbs down impressions you got, and you can see if your new model is better than the existing stuff, right? Design principles, very briefly, right? If there's something non-reversible, you can ask your user for approval. You can surface errors. You can allow intervention, right? If your AI is sending emails, you can't take the email back, right? But dashboards can be upgraded after the fact. Yeah, I think that's the powerful takeaway. One last example from fintech, right? For example, we had one application where they figured out GPT-4 can take Excel files and answer basic questions about them, right? But GPT-4 sometimes makes like numerical errors because it's not great at like 4-digit multiplication, that kind of stuff. So what we did is basically build a small AI that can take some of the rows from Excel, highlight them to the user, show which formula was being used, and kind of like in a calculator way, shows that which values go into which variable, what is the result, and you know this one is correct because the calculation was done by Python. It was limited to which formulas could be used. GPT was only used to extract the information, and the user had to confirm that it was correct, right? If you have this in place, you can even fine-tune for every single user. Hey, this user, we use their thumbs up, thumbs down for like a grid search or Bayesian optimization of their user settings, right? How in the RAG pipeline are specific documents weighted, specific things weighted to make the search perfect for that user. Right, that's it. Thank you so much. Any questions? All right, thank you.
Thank you, Max. Probably I have no real time for questions at the moment, but please do thank you, Max, and catch him later if you wish to speak to him. Okay, have an announcement.
Các bạn, ở phía trên này còn rất là nhiều chỗ, nên các bạn có thể phía dưới có thể ngồi lên phía trên này nhé. Các bạn có thể lên đây ngồi, mấy hàng này đều còn trống rất nhiều. Bây giờ mình có một cái announcement á, là cái phòng này hiện nay á, là đang về nói về AI. Các bạn ở phía dưới có thể lên trên đây ngồi. Tại thời điểm này á, thì ở cái phòng 101 á, đang nói về Web3 Workshop. Tại vì có một số bạn không biết á, là vô phòng nào, thì 101 đang là Web3 Workshop. 102 là nói về những cái topic chung chung về FOSS, nhiều cái technology khác nhau. Phòng 201 là nói về database Postgres. Phòng 202 là nói về cloud. Phòng 203 là nói về security. Các bạn ngồi ở phía dưới á, nếu các bạn có thể các bạn lên đây gần ở trên này ngồi một chút xíu nha. Rồi bây giờ chị lặp lại nữa cái phòng này. Bây giờ mình lặp lại lần nữa cái phòng này là nói về AI. Phòng 101 là Web3 Workshop. Phòng 201 là Database. Phòng 202 là Cloud. Phòng 203 là Security. Phòng 102 là FOSS, chủ đề tổng hợp.
Yeah, this one's tested, so may as well. So it was Hey Vu? Yep. Hey Vu. Okay. Okay, welcome everyone. Our next speaker is Hao Wen, speaking about open source data engineering and GenAI in building enterprise applications.
Hello, thank you. Xin chào tất cả các bạn đang trong văn phòng và các bạn đang theo dõi ở trên mạng. Thì tôi là Hải Vũ, tôi đến từ công ty EMIP. EMIP thì đã có một cái truyền thống phát triển về phần mềm từ khoảng gần 20 năm nay. Thì mấy năm gần đây thì chúng tôi nhận thấy rằng là trong các yêu cầu của khách hàng cũng như trong các sản phẩm của chúng tôi rất cần phải đưa nhiều cái phần về ứng dụng về phân tích dữ liệu cũng như trí tuệ nhân tạo và mảng security. Đấy, thì mấy năm gần đây là chúng tôi đang tập trung vào vấn đề đấy. Hôm nay tôi vinh dự chia sẻ với các bạn một số nét chính liên quan đến phần data và phần AI. Trong đó phần AI sẽ tập trung đến phần Generative AI, tức là AI tạo sinh, mà cụ thể là hệ thống RAG. Thì việc trình bày sẽ có hai phần, một phần liên quan đến phần data platform, một phần thứ hai thì liên quan đến Retrieval, Augmented Generation. Đấy. Thì để chúng ta ở trên cùng một cái background thì tôi xin chia sẻ một chút về cái bức tranh chung về phần data platform, data stack. Thì có thể là rất nhiều các bạn đang làm, các bạn làm trong việc lĩnh vực dữ liệu thì chắc chắn là sẽ phải biết rất nhiều về data stack, rất nhiều vendor. Và đặc điểm của những cái data stack này là nó có rất nhiều vendor. Có thể nói là thống kê phải đến hơn 150 vendor khác nhau, tức là cái hệ sinh thái của data vô cùng lớn. Tuy nhiên khi mà hệ sinh thái vô cùng lớn thì bao giờ chúng ta cũng thấy rằng là sẽ phải xuất hiện những cái tiêu chuẩn. Đấy, thì hiện nay đang thấy một số cái tiêu chuẩn đã được de facto standard đang được xuất hiện. Nó xuất hiện ở cái mức thấp nhất của cái stack. Đấy, điều này cũng khá là ngạc nhiên, vì nếu chúng ta gặp nhiều bạn ở đây sẽ làm về viễn thông, đúng không ạ? Trong viễn thông thì quan trọng nhất là chúng ta phải có những cái tiêu chuẩn, tiêu chí khi có nhiều vendor. Đấy, nhưng mà số lượng vendor trong data nó còn lớn hơn số lượng vendor của viễn thông, cũng khá. Thứ hai là AI tạo sinh. Thế AI tạo sinh thì về mặt consumer application này chúng ta đã biết đến chatbot, nhưng enterprise application đấy, thì các vấn đề sẽ là làm thế nào để sử dụng AI tạo sinh, large language model cho các cái tác vụ gọi là knowledge intensive, tức là những việc mà phải nhiều khi phải giống như một người, chúng ta phải đọc ở tài liệu này, tài liệu kia, chúng ta phải kết hợp lại, chúng ta phải suy ngẫm lại thì mới tạo ra được kết quả. Thì Retrieval Augmented Generation chính là sự được kết hợp giữa cái Large Language Model và các cái phương pháp truy xuất những cái dữ liệu trong cái cơ sở dữ liệu của doanh nghiệp để tạo ra, để cung cấp các dịch vụ về Knowledge Intensive Task như thế này. Về nguồn mở thì nguồn mở sẽ đóng vai trò quan trọng cả trong phần data và AI, và chúng ta sẽ thấy rằng là ngày càng có nhiều các cái phần mềm nguồn mở đảm bảo cái quality về chất lượng không hề thua kém các phần mềm commercial. Tất nhiên có một cái gap nhất định, sau một theo đo vào khoảng thời gian. Thì phần đầu tôi xin trình bày về các cái nền tảng. Khi mà chúng ta thiết kế một các cái nền tảng dữ liệu thì bản thân đơn vị EMIP chúng tôi cũng sẽ làm phải rất nhiều thành phần. Cái phần quan trọng nhất mà hầu như tất cả các bạn sẽ làm đó là phần chính giữa, tức là chúng ta sẽ quan tâm đến là query engine là gì, computing engine là gì, vân vân. Storage engine là như thế nào. Phần trên đấy chúng ta sẽ quan tâm hơn khi các bạn làm nhiều về phần data analytics, tức là data transformation. Đấy, nhiều cái toolkit, tất cả những cái component này đều có các giải pháp open source available. Bên trái là liên quan đến data ingestion, chúng ta sẽ thấy rất nhiều công cụ để làm tích hợp dữ liệu như thế nào để làm cho cái công việc của mình nó đơn giản và dễ dàng. Đấy. Và chia sẻ dữ liệu. Còn cái phần trên là khi chúng ta triển khai cho một doanh nghiệp lớn thì bao giờ cũng là access control, data governance, và sau đấy là nếu như nền tảng data platform này được ứng dụng cho một hệ sinh thái lớn thì có rất nhiều ứng dụng về marketing, về fraud, về tất nhiên là cả về BI và cả những ứng dụng về data collaboration. Thì hôm nay tôi chỉ xin tập trung vào cái phần màu đỏ ở phía dưới là phần storage layer. Storage layer không có nghĩa rằng nó chỉ là file. Storage layer nó có một abstraction lớn hơn, nó là abstraction ở mức độ bảng. Tức là thay bằng chúng ta là phải dealing với file, với object store, thì bây giờ chúng ta dealing với bảng. Và cái abstraction này nó mất khoảng 8-9 năm để cho thế giới bắt đầu nghĩ ra cái việc điều đấy. Đấy, thì nó rất là fundamental. Giống như chúng ta xây một ngôi nhà thì cái phần màu đỏ đây chính là cái nền móng của ngôi nhà. Chúng ta đơn giản hóa cái bức tranh phía trên đi một chút, thấy rằng cái phần nền móng mà tôi vừa nói nó chính là phần table abstraction storage layer. Phần trên sẽ là nhiều cái phần computing gồm các cái computing engine mà các bạn đấy chắc chắn đã dùng, Spark, Trino, Flink, vân vân. Phần trên nữa là phần control plane, đấy, tức là phần để tạo ra các service dựa trên những cái dịch vụ ở phía dưới, để qua đó chúng ta xây dựng được một cái data platform. Nếu các bạn tự xây dựng cho mình một nền tảng data platform, chắc chắn cái phần value added lớn nhất của các bạn sẽ nằm ở phần trên chứ không phải nằm ở phần dưới. Tức là từ phần control layer trở lên. Xu thế hiện nay là ngoài những cái phần mềm open source ở phần dưới thì bắt đầu xuất hiện một số cái open source ngay cả ở phía trên. Điều đấy có nghĩa rằng với những công cụ open source mới, chúng ta có nhiều thời gian hơn để tập trung cho các phần layer phía trên. Đấy. Trong tất cả những các sản phẩm data platform hoặc là data stack của thế giới, chưa sản phẩm nào của Việt Nam. Đấy. Cho nên là đây cũng là một cơ hội để chúng ta rút ngắn khoảng cách nếu chúng ta muốn tự xây dựng một nền tảng riêng cho Việt Nam. Thì cái table format và cái storage system này tại sao nó lại quan trọng như vậy? Bởi vì chúng ta đã biết rằng là có sự cái lake house là một sự kết hợp giữa data lake và data warehouse. Data lake thì là rất là rẻ và mở, còn data warehouse thì bản chất là rất an toàn, transaction vân vân. Thì cái bài toán đặt ra cho cái table format, cái storage system này là gì? Là phải hỗ trợ rất nhiều tính năng từ data warehouse. Đâu đó chúng ta lấy tất cả những tính năng của data warehouse và đưa vào data lake. Đấy. Ngoài tính năng ACID chúng ta đã quen, còn nhiều cái tính năng rất là cơ bản khác phục vụ cho data warehouse khi nó vận hành trong một môi trường production. Thứ hai là nó phải, cái abstraction layer này nó phải cho phép là sử dụng với nhiều cái processing engine khác nhau. Đấy. Thứ ba, nó phải tận dụng được cái lớp storage ở phía dưới, và hiện nay nó sẽ là S3 object storage vân vân. Thì đấy là vì cái storage layer hiện nay là chi phí rất là thấp. Đấy, trên đấy cũng là một mục tiêu của cái lớp storage layer. Và cuối cùng là nó phải đáp ứng được rất nhiều cái workload. Workload là gì? Có những cái workload mà heavy workload update liên tục, có những workload mà chúng ta phải append thôi. Ví dụ như là log monitoring thường là append. Đấy, nhưng mà những cái vấn đề trong thương mại điện tử nhiều khi lại hoặc là lại phần có heavy workload. Đấy, thì đấy là cái bài toán đặt ra cho cái storage system này. Chắc chắn là khi chúng ta mới nghe đến hệ thống này chúng ta thấy rất là đơn giản, bởi vì nó đâu đó nó chỉ là một cái format, tức là rằng với cái table format này thì nó abstract là ở dưới là các cái file như thế nào. Tức là bạn là một người lập trình, bạn chỉ quan tâm đến việc tôi phải làm việc với cái table abstraction system này như thế nào. Thế thì bên cạnh cái format, cái việc gọi là trả lời các câu hỏi là data nào, file nào nằm dưới một cái table, thì cái storage abstraction này nó còn phải trả lời một câu hỏi nữa, rất nhiều các câu hỏi nữa. Ví dụ như là cái hệ thống này kết nối được với bao nhiêu các cái engine khác nhau, và đâu đó nó khoảng, thực tế nó khoảng 10 đến 15 engine khác nhau. Chúng ta thấy là có khoảng hơn 150 vendor khác nhau về data stack. Riêng đến computing engine và query engine, so về cái mặt gọi là popularity thì đâu đó cũng phải đáp ứng khoảng 10 đến 15. Đấy, tức là cái table abstraction này phải đáp ứng được việc là cho phép các cái engine như vậy truy vấn trên dữ liệu của nó. Rồi nếu các bạn đi sâu hơn, bạn sẽ thấy là những cái vấn đề chi tiết hơn như là copy on write, merge on read, tức là các cái phương pháp, các cái kỹ thuật để làm thế nào để chúng ta có thể, hệ thống có thể query được hiệu năng cao khi mà dữ liệu liên tục đi vào hệ thống, liên tục được cập nhật. Time travel, chúng ta có muốn quay lại để tìm xem là tại cách đây một tuần thì hệ thống trông như thế nào. Concurrency, rất nhiều ứng dụng, hàng trăm người dùng đọc viết khác nhau, làm thế nào thực hiện tất cả những việc đấy một cách là an toàn và consistent. File pooling, khi chúng ta mà query một cái bảng chẳng hạn, thì chúng ta không nhất thiết phải đọc hết tất cả các dữ liệu, mà có khi chỉ dựa trên những cái statistics, dựa trên đặc điểm của cái query để ta lựa chọn ra dữ liệu nào cần phải đọc, vân vân, và rất nhiều cái tính năng khác, schema evolution, compaction, data quality, vân vân. Slide này nó cho thấy chúng ta rằng là chúng ta nếu chúng ta nắm được tất cả những cái concept như vậy thì chúng ta sẽ leverage được nó để việc xây dựng cho cái nền tảng data platform của mình. Đấy thì đây là các cái điểm mà để nói lên cái ý nghĩa và cái sự quan trọng của cái table abstraction này. Thì hiện nay thì ở trên thế giới thì có 3 cái tiêu chuẩn Apache Hudi, Apache Iceberg và Delta Lake, là ba cái de facto standard cho cái table format abstraction, và nó khác nhau. Thì ở trên thì chúng ta thấy là nó khác, đấy là các cái feature, những cái tính năng mà chúng ta nhìn thấy. Nhưng cái khác nhau nữa, người ta còn nghiên cứu là khác nhau ở từ phía dưới, tức là cái tại sao nó lại các hệ thống này khác nhau như thế đấy. Đấy thì đây là một số cái điểm chính mà sẽ thể hiện cái sự khác nhau của 3 cái chuẩn đấy. Thì một cái thì điểm đầu tiên tôi muốn nói đây là xuất hiện ra một cái tiêu chuẩn mới về table abstraction, gồm có Iceberg, Hudi, Delta Lake, và là những người developer chúng ta rất cần phải nắm được ba cái tiêu chuẩn này để xây dựng các nền tảng data platform. Điều thứ hai tôi muốn chia sẻ ở đây là các cái data tool nó đang trong thời gian gần đây đang được chuyển dịch để tạo ra, để rất là phù hợp với cái môi trường cloud. Thế nào là phù hợp với môi trường cloud? Tức là nó phải tận dụng được cái object storage, nó phải hỗ trợ cái là independent scaling của computing và storage. Bởi vì khi trên môi trường cloud thì cái dịch vụ gọi là S3 nó rất là rẻ. Đấy. Thứ hai nữa là bao giờ chúng ta cũng muốn là leverage cái containerized workload và scale được computing và storage độc lập với nhau. Thì đây là hai cái yêu cầu lớn, và ngay cả những cái phần mềm, những cái công cụ dữ liệu mà các bạn có thể đã rất là quen như là Kafka, như là Flink, ClickHouse hoặc là OLAP Analytics, thì nó cũng phải mất thời gian để chuyển dịch lên cloud. Thì Kafka khi muốn chuyển thành Kafka Cloud đều phải là chuyển dịch. Chúng ta thấy rằng là ngay ở khi thiết kế ban đầu họ đã thiết kế có sự coupling nhất định. Kafka thì có sự coupling trong Kafka Broker, sau này mới có những cái tính năng là Kafka có thể lưu trữ một thời gian rất là dài. Thế đây là những tính năng mới sắp xuất hiện. Flink cũng như vậy. Thì Flink gồm có Task Manager và các cái Task Manager thì cũng có sự coupling giữa việc control và tính toán và storage. Đấy thì họ đều phải thiết kế lại. Đấy. Thì thời gian gần đây, đây là cái rất là mới, thời gian gần đây thì chúng ta thấy rằng là các cái phần mềm đều phải thiết kế lại để đáp ứng được những nhu cầu như vậy. Cho nên nếu chúng ta làm những sản phẩm không phải trên cloud, thậm chí có thể là trên on-prem, chúng ta tận dụng cái năng lực object storage, chúng ta vẫn có thể áp dụng những cái tính năng mới này. Cái điều thứ ba tôi muốn chia sẻ một cái xu thế nữa, tức là cái phần real-time streaming. Real-time streaming này thì nói đến là các cái dịch vụ streaming chúng ta đã biết rồi, nhưng hiện nay ngay cả Flink cũng muốn là cung cấp các dịch vụ streaming với cái độ trễ thấp nhất là 0,1 dưới giây, 1 giây. Đấy, thì nó sẽ yêu cầu là một là injection vào là rất nhanh, hai là analytics query là rất nhanh. Thì đây là một số cái kỹ thuật để có thể đạt được cái gọi là streaming data lake house như vậy. Tóm lại đây là một số cái công cụ nguồn mở mà có thể các bạn sẽ phải quan tâm đến. Trong đó thì có rất nhiều cái stack ở phía dưới thì liên quan đến các cái công cụ như tôi đã nói là có Apache Iceberg, Delta Lake, Hudi, Đấy, rồi có những cái phần mềm là cho phép là tương tác cả 3 cái format với nhau, như là tôi không vẽ viết ở trên này. Đấy, thì có một số phần mềm nó cho phép là cả 3 cái format này có thể tương tác được với nhau và nhiều các cái ứng dụng khác nữa. Đấy, thì đây là một số cái open stack mà chắc chắn các bạn sẽ có thể dùng tới. Chuyển sang phần thứ hai thì liên quan đến Retrieval Augmented Generation, thì câu hỏi sẽ là tại sao, cái phần trước anh Max cũng có đã nhắc tới cái phần này, thì câu hỏi sẽ là tại sao là chúng ta lại kết hợp giữa Large Language Model với cả một cái hệ thống của Retrieval. Retrieval là một nhiệm vụ là truy xuất tất cả các dữ liệu, nó có thể đến từ các cái tài liệu phi cấu trúc, các cái bảng, các cái knowledge graph của doanh nghiệp, thậm chí là các kết quả tìm kiếm kết hợp với LLM. Thì ta biết rằng là cái năng lực của LLM và năng lực của Retrieval được kết hợp lại trong cái hệ thống này. Đấy, thì năng lực của LLM là gì? Chúng ta đã biết, một là nó nói rất là trôi chảy, tức là language understanding, rất là hiểu, tạo được ra được ngôn ngữ. Thứ hai là in context learning và instruction following. Đấy, instruction following có nghĩa rằng là sau khi đã được huấn luyện, đã được pre-train thì chúng ta có thể fine tune theo một số cái tác vụ nhất định và nó sẽ học được cái tác vụ đấy. Đây là instruction following. Đấy, còn in context learning là thậm chí chúng ta không cần phải fine tune, nhưng mà khi thực hiện inference thì chúng ta có thể đưa ra cái instruction để nó follow. Đấy, thì đây là in context learning. Và một năng lực nữa, cao hơn nữa, tức là zero shot prompting. Thậm chí chúng ta cũng không fine tuning, chúng ta cũng không phải huấn luyện trước mà LLM vẫn trả lời được. Thì đấy là những cái tính năng rất là đặc biệt, nó gọi là immersion capability của LLM. Đấy, thì tuy nhiên cái phần màu xanh là cái phần nổi trội, tức là phần positive, thế còn phần negative của nó sẽ là hallucination, rồi đã không biết là tại sao LLM lại trả lời như vậy và rất là khó kiểm soát. Thì nó được kết hợp với cái Retrieval. Retrieval bản thân đây cũng có thể là một model, đấy, mà nó cho phép là giải quyết cái bài toán là dữ liệu fresh thì cập nhật như thế nào. Knowledge editing tức là ví dụ tôi muốn thay đổi một cái thông tin ở trong cái hệ thống vừa rồi. Với nhiều hệ thống trong thương mại điện tử, ví dụ phải tuân theo các tiêu chuẩn là phải quên, tức là phải quên khách hàng đi. Đấy, nhất là ví dụ nghị định 13 của chính phủ ở Việt Nam cũng có là nghị định về bảo vệ dữ liệu cá nhân, đấy là phải khi mà khách hàng yêu cầu là cũng có thể phải quên dữ liệu khách hàng. Đấy, thì quên có nghĩa rằng là phải remove được cái knowledge khỏi hệ thống. Đấy, thì knowledge editing thì LLM không làm được, mà chúng ta phải dựa vào một hệ thống bên ngoài. Đấy, thì như vậy là ở đây chúng ta thấy cái sự kết hợp, cái Retrieval thì cung cấp các cái document để cho LLM, và ngược lại LLM thì lại cung cấp cái guiding cho Retrieval, tức là có một cái sự phối hợp và hợp tác với nhau để tạo ra một hệ thống. Thì cái đặc điểm của hệ thống này tôi muốn chia sẻ là nó rất là complex. Thì hiện nay là cái phần anh Max mà nãy cũng có đó chia sẻ một số về vấn đề RAG, thì nó rất là complex. Tức là ở đây một cái flow chung là đâu đó là chúng ta có một câu query, chúng ta có một tập document, chúng ta sử dụng cái Retrieval để truy vấn tất cả các cái query và document đó ở trên một cái embedding space. Đấy, so sánh nó với nhau, thực hiện những cái Retrieval, initial Retrieval, chúng ta re-rank nó, rồi sau đấy chúng ta kết hợp nó bằng các prompt template, kết hợp với context, với query, đưa vào LLM và LLM sẽ phản hồi ra một câu trả lời. Đấy, trong nhiều trường hợp cơ bản thì sẽ trả lời luôn, trong trường hợp advanced hơn thì có thể là iterative, tức là câu trả lời được quay lại hệ thống Retrieval để thực hiện thêm. Đấy, thì những cái phần mà chúng tôi bôi màu tím là những cái tính năng advanced, còn những cái phần màu đen ấy thì là những tính năng nó khá là cơ bản. Hiện nay thì chắc chắn nếu các bạn làm về AI là các bạn sẽ làm cái hệ thống này, bởi vì nói chung là đa số chúng ta không có khả năng tiếp cận trong việc là fine tuning cái LLM vì sự limit về hardware. Đấy, tuy nhiên trong cái design space cho hệ thống RAG này là vô cùng lớn, cho nên các bạn sẽ có rất nhiều cơ hội để làm cho hệ thống tốt hơn và optimize nó tốt hơn cho nhiều bài toán của chúng ta. Các bài toán downstream thì có rất nhiều, Q&A là một loại, nhưng mà Q&A cũng có rất nhiều loại. Ví dụ multi-hop Q&A, tức là Q&A mà dữ liệu nó phải nằm ở nhiều nơi khác nhau, phải kết hợp lại được với nhau, hoặc là long form Q&A, tức là không phải là truy xuất một thông tin mà nó phải trả lời, phải kết hợp nhiều thông tin từ nhiều cái, phải tư duy nhiều khác nhau. Đấy, summarization hoặc tạo ra những cái hội thoại recommend, fact checking và thậm chí là code generation, tức là rất nhiều ứng dụng nó có thể dùng cho hệ thống RAG này. Đấy thì thời gian có hạn thì tôi không thể đi vào chi tiết, tôi chỉ muốn nói rằng là cái design space của cái hệ thống này là vô cùng lớn và chúng ta có cách là bắt tay vào làm luôn. Nhưng chúng ta vẫn phải hiểu một cái bức tranh lớn và thực sự là phải bắt tay vào từng bài toán cụ thể của một doanh nghiệp để thử nghiệm. Đấy. Thì để muốn thử nghiệm chúng ta có rất nhiều thứ, rất nhiều cái công cụ muốn mở. Chắc chắn các bạn đã làm quen với Hugging Face, Llama Index, LangChain, vân vân. Thì cái xu thế ở đây là hệ thống RAG này nó không phải là hai hệ thống, nó không phải là Retrieval cộng LLM mà nó sẽ là rất nhiều thứ. Bạn phải chọn embedding model, các bạn phải chọn re-ranker, các phải làm những cái động tác là summarize. Tới đây mỗi cái này có thể là một component, nó là một cái viên gạch để tạo ra một hệ thống. Thì đây cũng là một xu thế, tức là chúng ta đang thiết kế một cái compound AI system. Đấy, và tất cả những việc thiết kế đấy hoàn toàn có thể dùng dựa trên nguồn mở. Thì với cái slide này tôi xin kết thúc phần trình bày ở đây. Tôi xin tóm tắt lại là một, nếu các bạn muốn xây dựng data platform thì chúng ta sẽ để ý đến những cái de facto standard mới, những cái nền tảng mới dựa trên cái abstraction của table format. Nó là một cái thứ nghe rất là đơn giản nhưng là vô cùng hữu ích trong việc xây dựng. Và nếu Việt Nam hoặc là các bạn muốn xây dựng một nền tảng data platform đầu tiên của Việt Nam thì các bạn bắt buộc phải dựa trên những cái standard như vậy, phải hiểu được cái phần phía sâu phía đó. Thứ hai là có rất nhiều các cái data tool hiện nay đang được thay đổi rất là nhiều, kể cả những cái công cụ chúng ta đã quen tên, biết rất là rõ, có rất nhiều feature mới mà chúng ta cần phải để ý tới. Thứ ba là phần real-time analytics, những cái dịch vụ liên quan đến real-time mà ở mức độ sub-second là đang có những cái giải pháp mới. Cuối cùng là cái phần RAG, như tôi đã nói, đây là một cái design space mà rất là evolving, thay đổi liên tục và là cơ hội cho các bạn trẻ để tiếp tục thử sức mình, tạo ra các sản phẩm mới. Và cái xu thế của GenAI chính là AI compound, trong đấy LLM chỉ là một component. Đấy, thì action chính là gì? Các bạn để Data AI Developer Architect hãy tập trung và tận dụng tất cả những công nghệ này. Hiện nay ở EMIP thì chúng tôi cũng thấy rằng là rất nhiều các cái đơn hàng của khách hàng đang đặt ra vấn đề như vậy, và các bạn có thể gặp gỡ chúng tôi để cùng xây dựng một cái Open Data Platform. EMIP cũng là thành viên của FOSSASIA, tức là câu lạc bộ phần mềm tự do và nguồn mở Việt Nam. Đấy, chúng tôi nếu các bạn có mong muốn tham gia thì có thể liên hệ trực tiếp với câu lạc bộ phần mềm tự do nguồn mở hoặc với chúng tôi trong việc xây dựng một cái nền tảng data platform mới. Thứ hai là chúng tôi cũng đang liên hệ với nhiều cái đối tác ở châu Âu để mong muốn xây dựng một cái Open LLM cho Việt Nam. Đấy, xin trân trọng cảm ơn.
Thank you very much, Hao Wen. You very much covered the open source ecosystem really well, so I'm very impressed. Do we have any questions? We've got about 5 minutes before Harish is up. Any questions? Hands up, because I won't see you otherwise.
Nếu các bạn không có câu hỏi thì các bạn có thể liên lạc qua email với tôi, email group Hải Vũ. Cảm ơn.
Actually, I've got a question. Which are the tools most in need of transforming to cloud native?
I think I just mentioned, the question is which tool are really transformative in terms of embracing cloud native, right? So I think we're talking about many computing engine, right? Also a lot of online analytic system. ClickHouse, for instance, they are online analytic system and they want to move to the cloud, and they want to, in order to do that, as I mentioned, they need to redesign the system to allow the independent scaling of compute and storage. So most of the tools need to redesign. Kafka, on the other example, Kafka also need to redesign to allow the decoupling of the storage in the Kafka broker. And now with the new feature, Kafka can allow to store the data in the long-term storage. So instead of, at the moment, just 7-day retention, Kafka allowed to store the data for a year, for instance. Right? So with that feature, Kafka can allow new business cases, Flink and many other. So, yeah. It's okay. Thank you.
No, thank you. Thank you. Great talk. Okay, everyone. Welcome, Harish, who's talking about a short history of artificial intelligence. Welcome.
Well, thank you. Good morning, everybody. Yay! I see a lot of familiar faces. I'm not sure I should be standing here in front of you. But good morning, and thank you very much for coming so early. What I would like to do is briefly give you an extremely short history of AI. There will be some inaccuracies because I wasn't there. So I have to depend a lot on other people's recollection. I also have to, read up stuff on Wikipedia and stuff like that. So I have to do the best I can. So please bear with me. I hope this will be useful for you. So let's go back to sometime in 1948. Anybody who was born in 1948 sitting in this audience? Wow, there's nobody. Okay, so I can say anything I want. Let me just play this video. It's about 2 minutes.
In a simple villa on the outskirts of Bristol lives Dr. Gray Walter, a neurologist, who makes robots as a hobby. They are small and he doesn't dress them up to look like men. He calls them tortoises. And so cunningly have their insides been designed that they respond to the stimuli of light and touch in a completely lifelike manner. This model is named Elsie, and she sees out of a photoelectric cell which rotates above her body. When light strikes the cell, driving and steering mechanism sends her hurrying towards it. But if she brushes against any object in her path, contacts are operated that turn the steering away, and so automatically she takes avoiding action. Mrs. Walter's pet is Elmer, Elsie's brother, in the darker vest. He works in exactly the same way. Dr. Walter says that his electronic toys work exactly as though they have a simple two-cell nervous system, and that with more cells they will be able to do many more tricks. Already Elsie has one up on Elmer. When her batteries begin to fail, she automatically runs home to her kennel for charging up, and in consequence can live a much gayer life.
All right, how many of you think there was any software running in that robot? Anybody thinking there is software in that robot? Raise your hands. Don't be shy. All right, one person. Well, unfortunately, the one person is wrong. There is actually no software inside. The entire robot is mechanical. It's all on gears and battery, and that's it. But it was still able to detect where it was and go back and avoid hitting something else, which is quite phenomenal for a mechanical robot, 100% mechanical robot. So you don't need software for that. But Today, we don't talk about that from that perspective. Sorry, let me just go back. Come on. Okay. Anybody recognize this guy? I'll tell you his name. His last name is Turing. What's his first name? Alan. So Alan Turing. Now, I deliberately made this picture with ones and zeros because I think that fits him very well. And he did propose something called the Turing test to test whether the thing that you are talking to, whether it is human or non-human. But the way he came to that idea was there was a paper he wrote in 1950. Anybody born in 1950 in this audience? Nobody, right? He wrote a paper, and in that paper he asked the question, can machines think? So he felt that that was the wrong question to ask. And he rephrased it and he called it the imitation game. How many of you think you have heard that phrase before? The imitation game. There is a movie called The Imitation Game, which is based on this. And it's all based on Alan Turing. So look it up, watch the movie later. But that's really a starting point for everything about AI. So fast forward a few years, in 1956, a bunch of people gathered at Dartmouth College in the US. It was led by this Professor John McCarthy, and he brought in a few other people, Marvin Minsky, Claude Shannon. Some of the names should ring a bell in a telecoms institute. So they came together, and eventually that discussion that went on for about 8 weeks, they coined the phrase artificial intelligence. Whether that's the right thing to have been done, we don't know, but that's what happened. But the problem in the early days was the kind of AI that was being done was really about logic, about playing games like chess. It's not even chess. You know checkers? It's not chess. It's the simpler. There's in England or at least in Singapore, we call it draft or the black and white checkerboards. So that's the game that this was initially written to play, to show that it can be done. Now, these are some of the guys who attended that first meeting in 1956. Yes, it's all guys. There are no ladies there, which we have to fix, and I think we have been fixing ever since. But nonetheless, they were the ones who set motion the idea of AI. And this is the commemorative plaque that is in Dartmouth College that says that this was the meeting, the room where it was held, and so on and so forth. This was actually put up in 2006 on the 50th anniversary. So what happened after that was the idea of a perceptron. The perceptron was actually an algorithm that was running in a piece of, in an IBM mainframe computer, the IBM 704. And basically what it was trying to do is to simulate how neurons work in software. And the researchers decided that they have to do something more than software. They decided to build a piece of hardware that actually implements the neurons. And that was called the Mark I perceptron. And I'll show you a picture shortly. But before that, this Mark I perceptron was the very, very first known implementation of an artificial neural network. We don't know anything else, but this is the only thing that we are aware of. Now, you may have heard of the term AI winter. AI winter basically suggests that all the work that was done suddenly becomes undoable to continue because either there was lack of funding, no more interest, so the entire interest just goes down. In the curve, you can see it is just falling off. So it was called first AI winter because this was actually a very difficult thing to do. It was not progressing as fast as we would like it to be. So, this was the very first Mark I perceptron, which is physically located right now at the Smithsonian Museum. But if you look at the size, it's probably the size of this entire projector. And this is just one neuron. So from the 70s onwards, there was additional research that went on to make sure that the other ideas could be developed. And the idea that most of us are familiar with from traditional AI is this thing called symbolic AI and knowledge representation. These are the two areas your traditional AI is known for. That evolved into expert systems. Expert systems are saying, like, I go to see a doctor and there's a bunch of questions and hopefully there's enough background information that can give you an answer. It's an expert system. And this was also limited because the knowledge engineering and reasoning was not good enough, not advanced enough to make it useful. From my personal perspective, the late 1980s, I was in school in the United States and I was doing AI-related work with my professor, and all the things that we did was expert systems, knowledge engineering, and to me that was very boring. I didn't enjoy the AI that was doing in the late 1980s. But it was interesting from my point of view because there is a possibility that something might happen later on. How many of you recognize this map? Anybody? Just put up your hand. All right, one person. Anybody else? All right, 2, 3. Okay, great. This was the map of the predecessor of the internet that you and I are all using right now. This is the map as of 1973. These were different nodes connected on this thing called ARPANET. Why am I showing this here? It's because you needed connectivity between different systems to do anything more than what happens within your lab, within your lab, your laptop, your desktop, your server. You need to have connectivity because you need to be able to engage with external systems. Now, of course, the internet doesn't look like this anymore. All right, it's much larger than this. So we fast forward into the 1980s and 1990s. A lot of new ways of doing stuff with statistical learning. The idea here is if you can go through dictionaries, language dictionaries to look at all the words, how frequently they appear in text, in books, and so on, and try and figure out what ways you can to analyze and do language translation, for example. So using statistical learning algorithms became an interesting idea that people were pursuing. One of the forms of that was something called a support vector machine. Don't worry about the term. The idea here is this was a form of a neural net. Not entirely accurately describing neural net in that sense, but it is a close representation to that. Again, the idea was to focus on data-driven approaches. What do I mean by data-driven? You need to have data in order to figure out what is it that you're trying to do. On its own, it's very difficult to figure out without corresponding data the type of outputs you're trying to achieve. Now, all of this laid the groundwork for future advances. What kind of groundwork do you think needed to be done? I showed you a map earlier of the ARPANET in 1973. Now let me show you the next one here. This was the infrastructure, the word I used, the groundwork. This was the groundwork that needed to be done so that we can do what we are doing today with AI and stuff, right? So this is from a website called Inframedia. All the lines you see are undersea cables, which probably most of them today are all fiber cables, so that it connects various countries around the world, and this gives you what is known today as the internet. the internet rides on these wires and these cables and these fiber optic connections between different parts of the planet. Because you can do this today, we now are in a far better position to now tackle the whole idea of AI. So with increased computational power, because our CPUs became better, we had more storage was getting cheaper. So now I can store information that now I can go and analyze later on because I have storage. If I can't store something, I can't do analysis. So it was many things that need to have happened before we can come to today in 2024 and talk about AI. So because of the fact that you had all of this additional stuff happening, it revived the idea of neural networks. When I was in school, we were talking about a 3-layer neural network: an input layer, a middle layer, and an output layer. I remember asking my professor, I said, "Isn't that too shallow?" He said, "Well, that's the best we can do. Because we didn't have hardware, we couldn't do a lot of things. But the brain is not like that. The brain has got multiple layers. How many layers do we need? I don't know." So today we can do that. We can have multiple layers, and that's why we are seeing what we are seeing today. So some of the breakthroughs that have happened because of the multiple layers you can go through is especially image recognition. I think image recognition is one of the earliest manifestations of AI usage that you and I can recognize. When you see in a camera, you see a little square coming up and say, "Oh, that's a face is there." Sometimes, I'm sure over the COVID period, when you had to go online and you have your camera on you, you can move away and put your photograph there. It will still pick up the photograph as if you are sitting there. And you can have your photograph next to you, and you have two heads. The system couldn't figure out there's supposed to be only one head, but it will still pick up the photograph. So you can still fool the system because the system is designed to pick up only faces, right? So it's interesting what can be done and what has been done, and now we need to move forward from there. We have this whole idea, I don't know how many of you would have heard, especially those of you who are industry in the 2010s, this whole idea of big data. Oh, we got a lot of data that we're going to be collecting, IoT data, information about your switches, your lights, your air conditioning, your traffic, all kinds of data. We want to collect all of these things. What do you want to do with it? We want to do some computation with it. The big data was what started then. And today you have big data sitting in all kinds of places. And the idea of this cloud computing. Remember, cloud computers is nothing more than somebody else's computer. It's not yours, it's somebody else's. And you need to trust that cloud computer to do the right thing for you. All right? But nevertheless, cloud computing came forward because, firstly, you had the infrastructure in place, the data centers were being rolled out, CPU was getting cheaper, RAM was getting cheaper, storage was getting very, very cheap. So now I can store a lot of stuff. And that allowed the idea of making AI accessible to every one of us. So democratization of AI. So we move forward. Other ideas came along. Deep learning. What is deep learning? How do you really understand what is going on in a particular data set? These are applications that are currently being used in self-driving cars. It may work 99% of the time, but that 1% of time it doesn't work, it kills somebody, we have a problem. But yes, let's try, let's learn, let's figure out how to do this even better. The last bullet point is about ethical considerations for AI. As you have all of this data that you accumulate, what do you do with these things? What are the kind of uses are you going to use it for? What use cases will there be? Are you doing it fairly? Are you biased in terms of the analysis? What is it? We need to address these things today, because if we don't do it, it is going to be very difficult to go fix it later. Now, just a nice picture. I wanted to show you some colors. So let's go to the next one. So we have all of this stuff driven based on the usage of open source technology. None of whatever I spoke about could have happened if the code was not available for people to test out, to try, to share, to improve, to break it, to fix it, and make it even better. Open source has driven the way. And so two of the more popular ones for AI usage, PyTorch and TensorFlow, there are a lot more. I just highlighted two, mainly because I like the logos. So logos are kind of pretty, so I decided to put the logos up there. But the thing is, this is what is driving innovation across the industry. The likes of the various cloud service providers who are creating their own AI solutions could not have done any of this if it's not for open source software. It's impossible to do. So we move forward to, again, in this decade, the 2020s. We have, in today's context, the idea of a foundational model. The speaker earlier was talking about foundational models, LLMs, and so on. That's great, because now we have the opportunity to take a lot of data, billions and billions of words, images, audio, video, and to do something with it. What is the something? To make it useful for you to make analysis so that you can act on it for some other use case. I wanted to highlight a few things that has happened in the last maybe 3 years, 2 to 3 years. When you have many models, foundational models, whether it's a large language model, a small language model, SLM or LLM, I don't care which one it is, you're not restricted to only using one. You can use many. If I'm going to use many of this at the same time, how would I do that? So there is this concept called mixture of experts. So you have a piece of software that runs in front of a bunch of language models, foundation models, and this front end will decide which of these to send the data to, your queries, your prompts, and so on. Now, this allows you to have a very, very useful and powerful way to do AI-related work from a generative AI perspective. And because, again, to me, open source is the bottom line for everything, there is an open MOE project that has been done, and you're welcome to participate and contribute to how do you do the front end so that you can now talk to language models that are open source at the back end. Now, again, the speaker earlier talked about retrieval augmented generation. I think this is a great idea. This is really what a lot of us require. If I can have a language model that then reads my data in my own environment, I don't want to send it to the cloud. I want to only have it in my environment, maybe my laptop, maybe my server in my organization or in my local area network or at home. I want to now let it search my email, my PDFs, my spreadsheets. I don't care what I have. I want you to read that, and then when I ask this language model something, it should be able to give me an answer. Now that to me makes a lot of sense from a generative AI perspective for you and I to use. So the RAG is a great way to do that. Again, other things that we need to also do today, things like testing of AI solutions. You need to always be testing. You need to make sure that when you deploy a solution that it's not going to be unfair, it's going to be unbiased, it's going to be transparent, and you can explain why does that AI solution do what it does. So I'm representing AI Verify Foundation. We are based in Singapore, and we do have a bunch of software tools called AI Verify Toolkit, which is on GitHub. It's on an Apache license. So please take that. improve it, give us feedback, see what makes sense, and let's make this work for not only for the geeks in this audience, but for everybody else on the planet, so that we can all collectively do better. And so what's the future? The future is there will be a term that you will see, sovereign AI. The sovereign AI is about nation states wanting to do their own AI. That means a country wanting to do their own AI. Another one which I am very excited to also be part of is something called Kwai. This is personal AI. That means you have your own stuff for yourself. And the last one is we have a bunch of frameworks that the AI Verify Foundation has put out on governance. So please visit our website to see what that is and be able to collaborate and contribute to it. So these are all the links that I had. And with that, I thank you very much. And you can join us on Matrix. We have our entire chat community and the community for AI Verify on Matrix. So you're welcome to join us. Thank you very much.
Thank you very much, Harish. Okay, our next speaker is Frank from Nextcloud, who's going to be talking about artificial intelligence in Nextcloud.
Thanks a lot. Really great to be here again. One of my favorite conferences here, FOSSASIA, so I'm really happy to be back. And of course, I have the same boring topic as everybody to talk about AI. It's the hot new thing at the moment, and there's a lot of things to consider. Yeah, introduction of myself a little bit. I'm the founder and CEO of Nextcloud. I'm doing open source for 25 years. Yes, I'm old. I think it was even before the term open source was created. But of course, nowadays, I'm doing mostly Nextcloud. This is why I was invited. And we have some new challenges now with AI that I want to talk about today. So, the goal when I started Nextcloud was to be an alternative to this guys here. And I mean, at a time, like 12 years ago, we're moving into a world where some like 5 big companies are getting control of all our data, all our communication. They're sucking up all our IT infrastructure, all our communication, everything we do. So we move into a world, of a dystopian world, where some like big companies control everything we do in our digital world. So this is a dystopia from my perspective, and this is what I tried to solve with Nextcloud. So Nextcloud is, of course, an open source alternative to Microsoft 365, to Google Workspace, to Slack, Zoom, Dropbox, and so on. The difference is, obviously, that Nextcloud is open source, and you can run it completely on-premise on your own infrastructure as you want. So Nextcloud gives you control back over your data and your communication. You don't have to give everything you do to these big tech companies. You can just take the software, it's completely open source, put it like on a Raspberry Pi or some bigger machine, and then you're in control of your data. You have everything local and under your control. You can look into the source code, and this gives you the privacy and security you want. This is why we have structured our product in these 4 areas. Nextcloud Files is for files you can share, like Dropbox. Nextcloud Talk is for chat and video conferencing. There's Groupware for mail, calendar, contacts, and there's Office for editing Office documents. Very similar, as you know, from Google, Microsoft, and others. A little bit of an overview. This is Nextcloud Files. Everything you expect. You can upload and download your files. You can share them. You can version them. You can delete and undelete them. You can search them. Everything you expect. Then there's Nextcloud Talk, of course, for chat and video conferencing. This is the chat interface, very similar to Slack or Teams. Then, of course, you can press a button and turn it into a video call. We also have like iOS and Android clients with push notifications and chat, everything you expect. Again, everything open source, everything locally running. Then it's, of course, Groupware for mail, calendar, and contacts. Everything you expect there. Very powerful mail client to manage all your emails with priority inbox, with searching, everything you expect. And Nextcloud Office for editing Office documents. Again, everything open source and everything local and everything great. So I'm happy to say that we are like the alternative to Microsoft if you care about FOSS and about open source. this is what we did. Was the situation like a year ago. And then came AI. And then everything changed. Because I have to say, first of all, I got a little bit of a depression here because I was like thinking, okay, shit, like, can we really do the same thing that Microsoft and Google are doing? Can we do as a small company, as a small open source project, can we really compete with all these AI features that these big tech companies are doing? Are we really able to compete with just a few people? And second is, even if we could, do we even want to? Because AI comes with a lot of ethical and tricky privacy questions. So even if we could implement everything with AI, do we even want to? Is this the right thing to do with our mission? Because as I told you earlier, our goal is to give people control over their data, to get everything open source, everything transparent. Is this AI thing even compatible with these ideals in this vision? Because as you know, AI comes with a lot of different things. First of all, it comes with good things, right? It can be your assistant, it can be your helper, it can support you, make your life easier, and like just remove boring tasks from you, right? But of course, it also comes with some problems. It comes with some dark sides, right? And there are some ethical considerations. So how do we deal with that? Right? And we are not the only ones with these ethical considerations. I mean, here's just a few articles from the press. There are companies like Apple and Samsung and Goldman Sachs and many others, and they're banning the use of ChatGPT and Copilot and other solutions. They're banning it internally in the organization. So why is that? First of all, there's the challenge of like misinformation. That is a real problem with AI and it's still unsolved. And second, there's also the privacy and security question, because it is absolutely possible that one company is asking ChatGPT for some feedback of some new document, some contract, some concepts, whatever. And then like another company comes along, the competitor, and they ask the similar questions and they get answers based on the documents of the competitor, right? Because this goes into the training data and that's a real problem. So there's a lot of ethical considerations around AI. And this brought us to the point that we said, okay, first of all, we need to try to compete with big tech here. We want to try to do everything as open source. And so we formed our own team. So like a bit over a year ago, we formed our own dedicated AI team at Nextcloud to work on those things. And second is, we had a lot of discussions internally and externally of Nextcloud with experts to think about ethical AI. So is there something we can do to create like a framework to put this all into the right perspective to make sure that we have the right ethical consideration? Of course, you ask, okay, ethical AI, big term, right? What do you mean? Ethical is great, but what are the details here? So it's of course not very hard to find the potential problems with AI. You just need to look a little bit into the press. You need to read some articles. So the first question is, of course, discrimination, right? A lot of these AI models, they are trained on the internet, and the internet is not exactly diverse and fair, right? So obviously these models also have the same problems. For example, if you ask an image generator, hey, can you please generate a photo of a doctor? Then you probably get a photo of a white man, right? Because this is how most doctors on the internet look like, and this is obviously a problem. So what can we do here? Is this a good thing to go down this route or not? Second question, what about the CO2 emissions? I mean, all these big hosting centers with these gigantic numbers of GPUs, they generate a huge amount of CO2 by consuming lots of electricity. Is this something good? Is this ethical? Does this fit the Nextcloud values or not? Should we do this or not? Next is the privacy aspect. As I said earlier, there's a danger of that some data is leaking from one organization to another based on the training data. This is something to consider. Again, is this something we should do or not? And then, of course, there's the question, is it all freely available? One of the big benefits of Nextcloud is everything we do is open source and free. You can just go to the website and download it for free. Obviously, Copilot and other solutions are not free. You need to pay for that monthly as a subscription. So are these new AI features actually available to everybody, or just available for some people who can afford it? So these are all really important questions that we wanted to answer. So what we did then is we created this ethical AI framework where we said, okay, we want to rate all AI systems on the internet and all the things we also do internally based on this system. And we have this traffic light system from green, where everything is like ethical according to our standards, and red, which is not. And this is measured based on 3 requirements. First, code should be open source. I mean, this is an open source event here. Obviously, the code should be open source. Why is this important? Because then you can run it locally, you can measure the energy consumption, you can optimize it, you can improve it, so having the code open source is very important. Second is the model should be available, which means if the model is available, you can use it locally and run it locally in your secure environment. The leading AI systems at the moment, GPT-4, for example, are not available, right? I mean, it's a bit of a joke that OpenAI is called open. They are like most closed organization ever, right? So you can just use it, but you have no idea what's behind the black box. So this is not good. The model should be available. And then last but not least, the training data should also be available, because then you can look for biases, then you can look for things that are not good, you can improve it over time. But this is just really, really important. And if like all 3 requirements are fulfilled, then this is a green system. If none of it is fulfilled, this is a red system. So everything we do is then rated with the system. So you as a user, you can decide which feature to activate and what feature not to activate. But let's talk a bit about Nextcloud, what we actually do here. That's of course the important thing. The first is the strategy that we follow, that we always have the flexibility in our software. So this is the settings screen of Nextcloud. And you can just, for example, say, hey, for the translation system, I want to use like ChatGPT as a service over the internet, which is a red system because nothing is transparent. But if you want, you can do it. Or you can run a different model, which is completely open source and completely local. For example, the Opus model from Helsinki, and this runs completely locally in open source. And it's also easy to configure, and you have the choice. You can decide what you want to do. Same is with all other features. If you want to use speech-to-text features, you can decide to use a service on the internet, or you can decide to reuse something completely open source running locally. And this is for all the features we do. So this gives you the transparency that you want. But this is mostly using other people's systems. Of course, we as Nextcloud, with our new AI team, we focus on developing AI systems and models that are completely local and completely open source. So let's go through this a little bit, and let me show you what we can do here. So there are a lot of different places where we already implemented AI features. This effort started like 2 years ago already with some smaller things like image recognition, face recognition. If you upload your photos, for example, we can already do that, and then search for it in the search. You can search for a dog and find all the photos from your vacation which contains a dog. So that's very straightforward. And we have some other features like suspicious login generation, related resources and other things. But it gets like really, really interesting when you look into the assistant, because this was our main effort like in the last like one little bit over a year, where we developed the Nextcloud Assistant. Nextcloud Assistant is something like the Copilot for Microsoft or similar solutions. And this is using a large language model. This is 100% open source and transparent. And this is 100% self-hosted. You can actually run this if you want on a Raspberry Pi. It is not super fast on a Raspberry Pi, but it works. And this is something like a, as I said, Copilot, completely open source and completely transparent, and according to our rating, an ethical and green AI system. So what can it do? It can do lots of things. The obvious thing is, of course, you can always activate it with a button and a top navigation, and you have an input where you can ask all kinds of questions, very similar to ChatGPT. That's obviously an easy feature. But then it becomes really powerful if you look into the integrations into the rest of Nextcloud. And let me show you some things. The first is integration Nextcloud Text. Nextcloud Text is our collaborative markdown editor that we have inside Nextcloud. And here's a quick video how this works. For example, if you have a text document, you just go into it. You want to mark a text. There's automatically the assistant popping up. You can say generate a headline, translate it, formulate it differently, make it a nicer text, or check for errors and all kinds of things, and it gives you an input, and with just one button you can insert the result back into the document. Like in this case, it generated a headline automatically based on the text. So this is a feature that is available everywhere in Nextcloud when you work with text. So this is a very nice, powerful feature. Then next example is mail. Nextcloud Mail is of course our integrated mail client, and it really has a number of interesting features. First of all, it has on the left side a priority inbox, so it can already learn and detect which mails are important for you and show you the important mails on top, priority inbox. Then we have a cool feature on the right side where on top of an email thread you get a summary of the email thread. Because sometimes, I don't know about you, sometimes you get so many emails you don't have the time to always read them. So you have a nice summary of an email thread on top here, which is very useful. Then obviously the Nextcloud Assistant can be used to generate a mail. Let's say you want to write a mail and you can say, hey, generate this mail to my marketing to blah, 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 and it automatically generates a mail for you. You can review it and you can just send it. Then a cool feature, and that we just launched like last month, part of the Assistant 2.0, is a feature where it can suggest replies to emails. So this is a system where you can just say, hey, I want to reply to this mail, and just give me a draft how a reply could look like, and it gives you a nice suggestion how this email reply should look like. Obviously, you should always proofread that, but that's very useful. And again, just let me stress, I think we're the only ones who can do this completely local and completely open source without using any whatever openAI or other systems. Then we have Nextcloud Talk, which is our chat and video conferencing tool. There are also lots of features where they use AI to improve the experience here. One is, of course, automatic translations, because we as Nextcloud, we are an international team. We have people in 22 countries, so we always communicate with different languages. So there's a feature built in where you can just automatically translate all chat messages in other languages, which is super useful to communicate with others. Then there's a feature, of course, for text, image generation. Let's say you want to visualize something, and here's the obviously needed cat picture. I mean, every presentation needs a cat picture. So here you can just generate a nice picture of a cat and automatically insert into the chat or anything else that's useful, which is sometimes nice for just for fun or to visualize or to brainstorm about something. Then, of course, you can always chat with the assistant directly in the chat itself. Let's say we have a project conversation, you talk with your colleague about something, and at any time you can just say, hey assistant, what are the most important things to organize a trade show? And it gives you the answers directly in the chat. So it's really like a human assistant that you can ask at any time anything, and the answer is just posted in your conversation with your colleagues, which is super useful. And then another feature of the Nextcloud Assistant 2.0 launched last month is the way to summarize chat conversations. I don't know about you, but sometimes the chat conversations can be very long. I mean, I'm part of the FOSSASIA Telegram channel here, and I don't know about you, I'm totally flooded. I cannot read anything, it's just too much. Here with the Nextcloud Assistant, you can just at any time say, hey, please summarize that, what happened since yesterday, and it gives you a nice summary of everything that was discussed in the chat conversation. Obviously, a super useful feature too. Then we have, as I showed earlier, also speech-to-text features where you can dictate. Some people like to dictate their emails or their chat messages. This is something you can do. But this is also a useful feature in other cases. For example, if you do a video call, you can, every video call Nextcloud Talk, you can get a recording, have a recording of your conversation, and you automatically get a transcript of every video call too, and also a summary of it, which is shared with everybody in the video call. So you always have a nice summary, what was discussed when, and this is also using our speech-to-text feature. So these are so far quite cool features, I think, but very standard, very straightforward. But we also want to innovate a little bit. And since half a year, we're working on a feature which I think is specifically cool. And this is something we call context chat. So that's the Nextcloud Assistant context chat. So what is that? Everything I showed you so far was a system where there's a model which was pre-trained somewhere or fine-tuned on some data somewhere, but the results are basically already in the model. Right? It doesn't really understand the context. It doesn't really understand your local data. So what we are doing here with the context chat is, from a technical side, to explain it a little bit, we use something that's called a vector database that is connected with a model with a tool called LangChain. This has the advantage that the assistant actually knows my data. So the Nextcloud assistant knows all my emails, it knows all my documents, it knows all my chat messages, all my calendar appointments and everything so on. So at any time you can ask, hey, can you please summarize the requests I got from Ross like last week? And of course the assistant knows all my emails and give you a nice summary about the communication that happens with Ross like in this time frame. That's a very powerful feature, and you can query and interact with everything that is in Nextcloud, again, completely local, completely on-premise, completely open source. I don't think there's anyone else who can do something like that. And of course, it can be also used in other places. For example, here's Nextcloud Deck. This is our project management tool. It's a Kanban board. You can say, hey, can you please give a summary how we typically organize events? And you can look through all the cards, everything in your project management tool, and give you a nice answer, looking at the past projects, last events, how this is usually done. And this is, I think, a very, very powerful tool. This feature also comes with a sister feature. This is something we call context write. This is also quite cool. This can generate documents based on an existing document with additional input. For example, you can say, hey, I want to take, I don't know, this PDF or this Excel sheet or something that I used in the past, and you take this as an input and say, okay, can you please generate a PDF very similar to this PDF, but with these changes, a little bit more funny, with, I don't know, different year, different dates, whatever, and it can generate a document based on the existing document with additional input. I think this is also super productive and super useful. So to summarize that, so my depression is a bit over now because I think my two challenges from a year ago we could solve. First is we could put all of that into an ethical context. We could say, okay, can we do this completely local? Can we have the training data completely transparent? Can we make sure that no data is floating anywhere else? Can we measure the CO2 output of the system and so on? And this is possible, and we make everything transparent here. And the second is, can we even compete with these big companies? And the answer is yes. Just to be clear, that's not all of us alone. As we learned at a previous presentation, there's a huge open source community around AI features now. And of course, we're working together with them. We have some of our own models, but others we work together with others. And this is really, really nice. So yes, the answer is the open source community can compete. We can do something that's better that comes from Google or Amazon or Microsoft or from others. So this is the end of my presentation. There's a last thing I want to mention, that we're also hiring. So Nextcloud is an organization, like a company, which is a little bit over 100 people now. I'm based in Germany, but we are international. We actually have people in 22 countries, and we're looking for help from people who are really interested in doing something ethical and good. Obviously, everybody who is interested in AI features, people who are interested in Python or PHP or JavaScript, Vue.js development, or if you're just a beginner and you're looking for an internship, then just go to our website or contact me directly. And I think together we can make the world a bit better in a nice open source way. Thanks a lot.
Well, Frank, well done. Yeah, thank you, Frank, for not only defining what open standards and openness means in a product, but actually implementing it all the way. So well done. Do we have any questions for Frank at the moment? Do you want to tell us what's next?
No questions, really.
Do you want to tell us
what's next?
What's next on your hit list of things to open?
Well, there is actually in 4 weeks there's the next major version coming, Nextcloud Hub 8.
Yeah.
Don't want to spoil too many details here, but there are a lot of cool new things available. And what's most fun for me always is not to copy what other people are doing, but also come with new creative ways to do things. And now with the AI features, there's a lot of possibilities to create like a work and communication environment, which is like just more productive, more fun and easy to use. So everybody who has creative ideas, then yeah.
Yes. With so much AI, do you know your staff's still there? I'm just wondering. No, excellent. Thank you very much,
Okay,
Frank.
thanks a lot.
It's my pleasure to introduce two presenters from Mercari. It's a special pleasure for me because I was working with them. They are ex-colleagues of mine. I recently changed. Somehow I'm still affiliated to Mercari. So it's Theo, Zosa and Chingis Oinar. They have worked on a lot of topics in Mercari. They will introduce the company with respect to machine learning for search and re-ranking. And it's my great pleasure to both chair them and also listen to the session to see what is going on. So please welcome the speakers, and we're looking for an interesting talk.
Yeah, thanks for the introduction, Norbert. And so, as mentioned, today we're going to be talking about how Mercari uses AI in search ranking and the subtle but key techniques that we've developed to unlock pretty strong business impact for Mercari. And so before we get started, a quick intro. So my name is Teo. I'm an ML engineer on the search team at Mercari. I'm one of the founding members that proposed and productionized the current AI search ranking system at Mercari, accompanied as well by my colleague and friend Chingis. Chingis, would you like to give a quick?
Hi everyone, Chingis. We are very happy to be here in Vietnam and in FOSSASIA Summit 2024.
Definitely, yeah, very happy to be here. So thanks, Chingis. And then after the personal intros are out of the way, a quick intro about Mercari. So we're actually Japan's largest C2C e-commerce marketplace. And for scale, we have numbers from our last fiscal year. Our GMV, which is basically the sum of all items sold across our platform that year, is about $6.5 billion USD. And net sales was about $1.12 billion USD. And Mercari actually started off as a marketplace app. We've since expanded to B2C, fintech, cryptocurrency exchange, a lot of different things to use our platform to combine users together to add a lot of value that way. But for now, in this talk, we'll be talking just about the marketplace app specifically. And so going into search at Mercari, drilling down a bit deeper, we have about 23 million monthly active users, just recently crossed the threshold for 3 billion listings in total. So that's the scale that we have to work with, especially for these real-time systems that we have at search. And search with that amount of listings and users is really the most fundamental way that users can find each other, buyers and sellers on our marketplace. And before AI, the core of this functionality is powered by Elasticsearch, so the search engine, which is a text-based search engine, where search results are retrieved and AI ranking can work on top of that. And so at a high level, it looks like this, where the first pass of the search engine will give us listings from our search engine result page, or SERP for short, all relevant to potentially a query. And what the AI re-ranking is supposed to do is supposed to act as this function in the middle and pass back re-ranked listings by relevancy, with the hypothesis being that more relevant listings will result in more user behavior, say purchases and engagement, which would be more revenue to the business. And so it's a win-win for both users and us as Mercari. And so some examples of that you can see right here, where you would have an original listing on the left, re-ranked listing on the right, and we can see that our ranking function, it does a good job of upvoting things that were, in this case, clicked or purchased. So those are two relevant signals that we have. And so this talk will be about that end-to-end process of how do we build this ranking function, this ranking model, and apply it on top of these search results. And so going from the very beginning, from data set construction, model tracking and monitoring, where I will then hand it off to my colleague Chingis for model building and debiasing, and then we'll just wrap up with some future directions. So data set construction. This is a really, in my opinion, really funny image that my colleague Chingis found from Reddit's actual own blog post on this same topic. And so I don't know if only 5% of our time is spent training the model, but it feels very much like this, where a lot of the time is spent early on with offline evaluation and data set construction, because there's a phrase in machine learning called garbage in, garbage out, where basically your model is generally only as good as the data you feed into it. So we spend most of our time here, even before the model building phase. And so the core task of re-ranking these, the process of training a re-ranking function is called learning to rank, and it's a core task in information retrieval in general. Prior, it traditionally relied on manual hand-annotated data sets from humans. The problem is that in the past, it's really expensive. You have to pay people to do it, expensive as far as time. It's not scalable at all because it's now you're bottlenecked by the humans that are in the loop, and it's stationary. And so you're unable to capture relevance that changes over time. Once these labels are made, that's it, and unless you revisit them, that's what you have to work with. So we solved that by, in 2024, learning from user behavior. So assuming that you have something that's user-facing, you have a critical mass of users, these user interactions, what we call implicit feedback, is quite prominent in existence. And so assuming you're logging all of this behavior, you can use this user behavior to determine what users actually prefer and use that as your annotations, which really solves all of the aforementioned problems. It does bring its own set of difficulties that my colleague Chingis will discuss in his section of the talk. But for now, it does solve at least the aforementioned problems. And so going back to relevance, and so this is actually one of the key but subtle techniques that you have to pay attention to, is that relevance really depends on your problem space. And so for us, we're a marketplace. Our users, at least from the most important part of the need of our users is to buy and sell in our marketplace. So for instance, purchases can be a very strong relevance signal, maybe the most important. We also have things like likes and comments. I'm sure many people here have been on platforms that have similar functionalities. Do those matter? We think they do for user engagement, but also too, they do actually predict purchases if that were the only important thing. And so we can even see that just thinking about something like likes and comments, they are correlated very strongly with purchases. The likelihood that you will buy something after you've commented is very high. And so we also want to prioritize those engagement signals as well, both for a healthy marketplace for longevity, as well as potentially purchasing, right? Which again is a win-win for both Mercari and our users. And so we can see an example of that. Our re-ranker actually not only upranks purchased items, but also liked items. So we can see here that this user actually liked 1, 2, 3, 4 items in this whole entire search result. And none of them were actually very high on the list in the original ranking. So we see that it's good at upranking both liked items as well as a purchased item, which, quick note actually, this purchased item was like 200 positions down the original listing. And so if we didn't have our re-ranker in play, then that user would have had to scroll through 200 items to eventually find what they did purchase. And then there may be a bit of bias because by then maybe you're tired, right? So if this didn't happen this early in the search result, then the user may not have actually purchased it at all. So this is how necessary search re-ranking can be to our, I guess, user experience. And so wrapping that all up, data set construction looks something like this, where you take one block of time, let's just say 1 month, and then you take the next block of time. A key technique to prevent something we call data leakage. You only validate on future data, never data that was in the same time period as what the model was trained on, because you want to make sure that when this is in production, this will actually accurately predict the future of unseen data. And then the relevance labels that we use from highest to lowest: purchase, checkout, comment, like. Another key technique we've used was other purchase behavior, because we use, as a CDC marketplace, we have unique items. We don't have a concept of stock. So even if you wanted to buy the item, if someone beat you to it, you didn't have a chance. Even though you could have had that high label, someone else bought it. So we want to capture this global behavior and kind of bring to the front something that we consider is maybe purchasable at the very least. And then clicks, sort of. Clicks are preconditions to all these other relevance labels. We don't use them directly at the moment, but a user had to at least have clicked on something for any of these other labels to have been applied. And so with that quick introduction out of the way, we can go into model tracking and monitoring. And so why would we want to track model performance? So really what matters to the business is user behavior, right? When you deploy this, do sales go up? Do likes, comments, does searching go up? The problem is that's very expensive as far as both time and cost, and it's very dangerous. What you really want to do is have a really good offline evaluation suite that you can iterate without high risk, as well as being able to iterate quickly. And so for this section of the talk, there you can technically think of online and offline model tracking. We're only going to focus on the offline part, which we think is the most useful and maybe the most applicable to the audience here. And so before we go into the offline evaluation, just some metrics that we use. In information retrieval and learning to rank, a classic metric was reciprocal rank, which basically said, give me, if the first relevant document was high up in the list, that's a high score. That doesn't necessarily work in our context because we have different relevance labels of different weight, and we don't necessarily just want one to be at the very top. We want as many as possible, the most relevant signals as possible, to be higher to the top. So if we have 10 likes in a purchase, we want that at the top versus just a like at the very first position. Which brings into play the next metric that we use, the one that we use most predominantly, called NDCG, or Normalized Discounted Cumulative Gain. It's a very long word. This is hopefully the most math you're going to see, at least for my section of the talk. All you have to understand here is that it normalizes it so that if you have a score of 1 on an ordered list of items, that means that's the most relevant most relevant ordering possible. Score of 0 is the least relevant ordering possible. So now we can use those scores offline for model tracking when we train these models, and we can say, okay, we have variant 1, variant N. Variant 1 had the highest score. Now, after we've iterated a few times, we can just put that into production in the A/B test and test it online with a high confidence that it will do well. And so, summing that up real quick, metrics we use, NDCG. We do use mean reciprocal rank. We use pair accuracy, average relevance position. Another key but subtle technique is expanding on these metrics for our problem domain. Again, something we recommend you do depending on what problems you have. So for us, again, purchases are pretty important. So not only do we have relevance for all engagement items, we say, well, what about just purchases? And so we have purchase NDCG. We have something called counterfactual NDCG that Chingis will talk about in his section of the talk, which basically is something like there are 2 potentially identically relevant items, but they may be at different positions in the search result, and we want to make sure that we account for that. And so, again, why custom metrics are important, blind spots of the standard metrics that are used in learning to rank. If you just looked at something like NDCG at different positions, the top 2 in the bottom left graph, you think, oh, wow, we're training this model. It looks fantastic. It's getting better and better over time. But then when we introduced purchase NDCG, something fairly recent in the past year, we would see, oh, wow, it's actually getting much worse over time. And so for a long time, we had problems really correlating our offline evaluation with online. And this is one of the key techniques that helped us to now close that gap. And we said, okay, this is why purchases aren't going up. It's getting better at other things, but getting worse at purchases. And again, we see similar behavior here. Comparing 2 re-rankers, the pink you would think is actually doing worse on standard metrics. But when you look at purchase NDCG, it's doing much, much better. And so in this case, it would give us pause, and we might actually think of testing and releasing the pink re-ranker as opposed to the blue one. In addition to quantitative, we have qualitative metrics. So search relevance, there's a lot of manual steps for quality assurance. And so in training, it's the same thing. We visualize the reorderings of each epoch of model training to make sure that the model is actually doing a reasonable job at re-ranking as far as, I guess, humans were concerned. And then the ways you would do model tracking and monitoring. So I'll kind of burn through this one a little quickly. There's the caveman way, which I still do, and many people still do. We all start with this, where we have experiments, we put them in folders, we have maybe an Excel sheet of parameters and results. It's not very scalable past maybe a dozen models, and it's rough, it's really hard. You can go all in on cloud, you can go all in-house. What's really worked well for us so far is this half and half approach of running experiments anywhere. So we have a lot of flexibility, but having a central place for storage, for logging, and being able to share this information. And so weights and biases has been really helpful here. And all of our previous graphs actually were using the weights and biases UI, being able to share those results not only with you, but with each other through offline eval. And then real quick, just because it's an open source conference, weights and biases is open source as a software. They have a paid offering, which is where you get the most benefit, which is like their cloud-hosted shareable dashboards. Though, if you're a researcher, if you're working on open source projects, they actually have free limits for you that are pretty fair, actually, pretty kind as the amount that you can use. And so, even so, we would encourage all of you here in the open source community to check this out, to try it out. Maybe if you have really good experiments, share it with us and with the community. And yeah. Okay, with that said, I'll pass it off to my colleague Chingis for model building.
Yep. Now moving on to the modeling side of things. Let's say you're building your own LTR solution, and here's a short list of candidates that you'll be able to find if you at least spend 5 minutes on Google. And as you see, it's very surprising to see so many options for Python. So it was a natural choice for us to go for Python. And then we have another decision to make. So at first, when you just start building your solution, you might go for very well-known machine learning packages such as scikit-learn or lightgbm. But then as time goes by, and if you're going in the right direction, you might start prioritizing richer LTR-specific capabilities. So in those kind of cases, you have other options that are based on some deep learning frameworks such as TensorFlow ranking, PyTorch, or JAX. But then another problem with all these deep learning frameworks is that not all of them are well maintained. So some of them are not even maintained anymore, and others are barely even maintained. So as much as we want to use and have a freedom of choosing deep learning frameworks we want, as a wise man says, if you cannot go against, then join. So that's how we ended up using TensorFlow ranking. And TensorFlow ranking is a very good machine learning tool. It is well maintained and actively maintained and developed by TF ranking team at Google. And also it supports and provides many LTR capabilities and state-of-the-art solutions, which includes loss function, metrics, and modeling sites, which we are gonna talk right now. So how you can approach LTR is there are 3 popular frameworks for model building, which is the first one, and very naive, is a pointwise, which considers documents independently in a way that you're able to model your problem in a regression or classification task. And then we have a pairwise, which is a bit tricky in a way that you want to learn or train a machine learning model that predicts higher scores for certain items than the other items. Like in these examples, if we care about cookies and if we want cookies over apples, then our function should predict a higher score for cookie over apple. And then if we like apples over pizza, the score for apple should be higher than pizza. And then the last but not least, and what we kind of use is a listwise approach. So listwise is a bit more complicated in a way that it considers the whole context, the whole, and you can look at it as a sequence-to-sequence prediction, where you have a sequence as an input. In our case, it's a list of items that we have at Mercari, and then our machine learning model produces a list of scores, which we use as relevant scores. So for our machine learning solution, we have 2 types of features that we differentiate by referring to them as the context or document features. So as document features, as the name suggests, it describes the documents or the listings we have on Mercari, such as their prices, freshness, title, and etc. And then we have context features. The context features, as the name suggests, describes the context of a search result page. It might be some statistics we calculate within the search result page and some other features. So as we know, machine learning models are very sensitive to scale, and also, yeah, they're very sensitive to input data scale. So that's why we have to deal with data normalization and pre-processing and etc. So for since we are mainly Japanese marketplace, to pre-process text data, we use Micap, which is an open source tool to tokenize Japanese text. And then some very well-known techniques for data normalization is z-score normalization, and then log1p transformation for numeric features. And here's a brief overview of what our model looks like. It's nothing very complicated. It's a very light MLP for nowadays scales. And we have some pre-processing there, and after that we run inference. So now we are moving on to debiasing stuff, which is a very tricky and very complicated topic in artificial intelligence. So the problem with bias that we have on our marketplace, since as Teo said, we use implicit feedback to train our models. Implicit feedback meaning the user engagement in form of likes, clicks, and purchases. So the implicit feedback brings two main difficulties. First is noise. So clicks might happen very unexpectedly in a very random behavior. Like some person might like a picture of anime girl and then the user clicks on it, or maybe a person doesn't like a picture, but user is still curious about why it appeared on the search result page and still clicks on it. So this happens very random. That's why we assume it's a random behavior, and that's why it can be averaged out with a very substantial amount of data. However, there's another guy called bias, and bias is very tricky problem, since we assume that bias is a very systematic behavior, and there are all kinds of biases. For example, position bias, it tells us that the items that appear on the top of the search result page usually get more engagement, like more likes, more clicks, more comments. And that introduces bias in data. And then with the bias data, we have bias model as well. For this presentation, we're talking about position bias, since that's something we are currently focused on. So this is a very common approach for the position bias. So the probabilistic model you see here, it says that the probability of you clicking an item depends on two things: whether it's relevant to you, and also whether you're able to see it and also evaluate whether it's relevant to you as well. So when those two conditions are met, only then you're able to click on the item. So how do we estimate position bias? So the very naive way and very simple way to estimate position bias place is to randomly shuffle items for users and then see how they behave and how they engage with items. So you just log the clicks, and then you observe how the click-through rate changed for different items. For example, we see after shuffling, if we calculate click-through rates for the same document, we might observe that click-through rate changed depending on the position of a document, or in other words, where the document appeared in your search result page, which is a very fair point, because if a document is very deep down in your search result page, you might be lazy to scroll down and find this document to be able to click on it. However, this approach is very expensive in a way that it also hurts user experience. If we just keep randomly shuffling documents, then our users will also be shocked because what they see is not what they expect. So that's why another approach is something called intervention harvesting. And it's a very convenient approach for many companies nowadays, especially for those companies who run a lot of A/B tests. So the underlying hypothesis here is that the inherent randomness in machine learning model kind of imitate random shuffling during A/B tests, because during A/B tests you might be testing multiple machine learning models. So since you A/B test different machine learning models, there's this kind of creates the shuffling. Yeah, and when we, however, it's also very tricky to compute using the A/B test data, since the shuffling is not completely uniform. So you have to be very careful when you calculate click-through rates, because also, as you see in this picture, not all documents appear in all the positions. Some documents might appear only in certain portion of position, and then some, so they get different treatments. However, if you are able to use that and accurately estimate position bias, this is something you might end up with. So this is what we have on our marketplace. So as you see here, this is kind of our layout on our marketplace. It's in a form of grid. We show 3 items per row, and we see that the listings that we have on top, they usually get much more engagement. People tend to comment and like much more. That's why they get much more engagement. And then after a few scrolls, we also notice that users generally try to engage with the central position as opposed to the right or left positions. Yeah, and as we told, this creates very biased data, and then we feed this biased data to the machine learning model, and then we get biased machine learning model, and the loop goes on and goes on. Yeah, so how we solve it? TensorFlow ranking allows us to use these estimated weights to apply in loss function. And then when we tried this approach, we observed that the performance on tail queries, which are least common queries in our marketplace, improved, but however, the model degraded on the head queries, which are the most popular queries in our marketplace. And the problem with the data and the traffic itself is that the majority traffic usually dictates all our metrics online and offline. That's why however, there's another approach. Instead of using those weights for a loss function, we can also debias our training data, because we suspect that we overpenalize our machine learning model. And when we apply those weights to our training data, we were able to see more promising results.
Thanks, Chingis. So for future direction, this is a little out of scope with the current talk, but it just tailwinded with the data or the debiasing section. So as Chingis mentioned, really paying attention to our data. We talked about in dataset construction phase, that takes a majority of our time. And even when training the models and applying these different kinds of approaches, it almost always goes back to how can we fit this into the data, because that has the highest impact. And so data debiasing is, I guess, a prominent area for future research for us. So the first is ingestion lag bias. So our re-ranker actually uses a lot of real-time information like clicks, views, things like this. And we want to make sure that all of the information the model is getting is true to reality at that time. So for instance, we don't want our infrastructure to take a day to process data. When you've clicked on it right now, that would be very useful for the model to know. Most of our items actually sell within 16 hours. So again, ingestion lag data bias is a big area that we're looking into. Also interaction context. So funny enough, we just talked about search re-ranking, but we actually have re-ranking across many different surfaces at Mercari. So recommendations, query autocomplete, many different areas. And right now, those are all trained in isolation, though you can see that they share a lot of similarities. And if you click an item on a recommended screen, shouldn't that be counted when you're searching the item itself and vice versa? So we're looking into how much of that actually generalizes across our different re-ranking surfaces at Mercari. And the last is candidate set bias. And so re-ranking is only as good as the results it gets into the ranking function. And so if all of the results are bad, there's no good re-ranking at all, right? Also, we want diversity. If you have all of the same item, the re-ranker can only do so much. And so our colleagues later are having a talk on how they use LLMs in the retrieval aspect of the search phase. And so their work is actually going to talk about how we address the candidate set bias as well. So I think that's it. Oh, and then we are hiring. And so for both internships and full-time positions, if you scan this QR code, go to the booth, talk to us. We have more information. And thank you for your time today.
Yeah. Thanks for this very interesting talk. I'm very happy to see how everything progresses here. Any questions from the audience concerning whatever, learning to rank, search, Mercari, or hiring? Yes.
Okay, first, thank you for your interesting presentation. I want to ask you that did you apply the re-ranking method into the production? And can you share some real result applying this? For example, increase in sale or ROI, something like that. That prove the approach works on production.
Confirming 100%, this has been deployed in production and been validated, and we've continually released features in production that have made the business impact. I didn't catch the last part of your question.
I want to know that so you are just not really apply into Mercari.
I think you cut out that last.
I just want to confirm that did you apply this new method to Mercari homepage, the production right now?
So we did apply it in production for the online A/B testing. Very close to deploying it in production, just working through the next iteration. Did you want to have more to add to that?
Yeah, and can you share any the real result after
regarding model debiasing? If you're also asking about this, we did run A/B test with this approach where we applied our estimated weights for position bias in a loss function. We did run A/B test. However, the A/B test was not completely successful because after investigation, we found out that the model improved performance on tail queries. Tail queries, we mean least popular queries on our marketplace. However, it degraded its performance on more popular queries on our marketplace. However, considering that those queries are more popular, they also represent the majority of our traffic on marketplace. And that's why the majority of our traffic also dictates our online metrics. And in that sense, and that's why the A/B test results were not very successful. However, after that, we did another iteration. We then applied to those weights to debias our training data instead of using them with the loss function. Since we think that we overpenalized our model, this is the results we got. So we did offline evaluation. On offline evaluation, it improved performance on both tail queries and head queries, which are more popular queries. However, we haven't run the A/B tests yet, but we are planning to do it.
Okay, thank you for your answer.
Thank you for the question.
Any further questions? Yes.
So the underlying search engine is all about Elasticsearch.
Is it right?
The underlying system before re-ranking, yes.
And it's all just about text search. Now I know that the vector search functionality has been added to the Elasticsearch.
Yes.
So your team will keep up with this and extend the ranking functionality to the image search too.
Great question. Yes, we're looking into that. And actually, as mentioned before, my colleagues that are in the audience right now, Miao and Lirong, their talk is in about like 3 hours. And they're going to talk about all the work on the retrieval side. So near Elasticsearch before and after that we're working towards.
All right. I will attend and to looking for more information.
Yes, thank you.
Thanks. We have Thorsten Neumann here talking about LLM, and he will give actually live presentations also. We hope everything works nicely. So look forward to an interesting talk and welcome the speaker.
Thank you very much. My name is Thorsten. I'm very glad to be here in Vietnam. I've been working with Vietnamese engineers for about 10 years already. Some of the best engineers I've worked with, so I'm very glad for all the talent that's developing. I'm going to tell you about some of the challenges about enterprise RAG and enterprise LLM. Many of you, of course, following all the models, Llama, Mistral, all those developments, but when you take it into a business and you take it into enterprise, it's a different type of challenge. I work for Standard Chartered Bank in a department called SC Ventures. We do innovation, but all the views are personal. So the bank might develop strategies in their own way, but these are my learnings to you. The recap, what we want to do is really just look at recent developments, very short. We want to step through some conceptual architecture of how to run these things in production. This is a bit experimental, and then a demo. And please, you might want to pay attention and not use all the bandwidth, otherwise my demo will suffer. I'm just kidding, but please do pay attention. So we're talking about enterprise capabilities, and so we're seeing an emergence, of course, of a lot of different models. You know, multimodal use cases. NLP has been around for a long time, but now also just the GPTs, the transformers. Computer vision, you know, in our bank, for instance, we process something like 40 million trade documents a year, right? These are like PDFs and faxes and all sorts of documents. We need to extract data out of the OCR. And audio is becoming popular, right? Voice generation, IVR systems. So we need an ability to manage all of this, and the organization needs to align around that, and that's not easy. And obviously, all have different skill sets, but if you put them into a picture, you probably fall into some of these different categories, and they have to work together, and they have to establish a process of taking the kind of concept of the model all the way through to production, and this is not always very easy. And you see there's a certain governance that's required too, in terms of what models you're developing, who's using them, when they get deployed, what versions, how to do the deployment themselves, and then very important also model serving. So all of you using chatgpt.com, openai.com is of course hosted externally. When you bring it into a business, you need some more robust infrastructure. What makes this all work is of course a lot of layers of technology. A caveat, the stuff is changing constantly. It makes it very difficult, even as an engineer, to keep up with all of that. Dependencies and all that, classes, projects changing, namespaces changing. But you know, in this case, I've taken a look at Ray, and Ray is an amazing runtime. It's also been used to train the OpenAI GPT-4 model and prior models. So it really serves as a complete suite, but you can run all sorts of tools on top of Ray. And so what I've kind of found in interacting with the corporate, with the bank, with my stakeholders, even with some of the ventures that we work with, we build startups within SC Ventures, so we have 25 startups who are adopting or looking at AI and ML is this kind of need to have a segregation between what is your internal AI and ML. So traditionally, you would have always, a bank, for instance, would have always had AI. I don't know about the Vietnamese banks, but certainly the international banks have for a very long time. Now, of course, extending that to language models. We then have third-party models, which are your SaaS providers and your Hugging Faces and external. And then lastly is your emergence of vector stores. I think there was a question earlier around some vector databases. But maybe also importantly, if you haven't, or if this space interests you, is to take a look at graphs, right? So I don't know how familiar you might be, but graphs play an important role in retrieval simply because it helps you navigate how you get to the right kind of documents and how you shortlist the relevant information. Bit of a tricky space because both vector databases are emerging, and there is, of course, plugins like PG Vector, but you have other competitors like Pinecone, Weaviant, Milvius, who are very strong vector databases. And you have graphs like Neo4j, strong graph database, but again, trying to bring the two together is still quite tricky at this time. Important is you kind of need three. You need all three of these capabilities. The reason is, a lot of the data in large corporates, if it's a telco, if it's a, I don't know, a conglomerate or a bank, is sensitive. So you want to potentially put that through your internal models. When your staff is making content for the website or some sort of LinkedIn post, they probably want to use a very strong model and maybe something like GPT or externally hosted Claude. And lastly, the data. You need to store the data somewhere, but these databases here aren't necessarily your source of record, right? They're like a temporal store or maybe a transient store. They get their data in from PDFs, from Word documents, from websites, from any other external records, processed into a certain format, embedded, and then stored in your vector databases. And so it kind of brought us to think about, like, how would we do this if we have to serve a whole bank, right? We have 100,000 staff in the bank. It operates across 59 countries. In my smaller type ventures, we've got little businesses in different geographies. And so we thought, okay, we have to put these components together. Very often what you'll find is that you might be building a model and you use, I don't know, fast API and you got the thing up and running, but it's not enterprise grade. Next thing, you have a bigger kind of company, I don't know, Viatel or other telco or corporate. They've got departments. They need to keep track of who's doing what, who has access to what models, who's calling which APIs, how much do we bill them. So you have all sorts of complexities in how you run internally. The other, of course, is that you need to build something scalable to serve these models, because as your consumption grows, you'll need GPUs, you'll need some sort of infrastructure in the back end that also allows these models to perform. And I was having a chat yesterday with Teo about Mercari, and again, you know, the big topic there, which maybe doesn't get enough attention, but is really performance, right? Into milliseconds and very high performant serving. So what we got here is a kind of a conceptual, approach where we're saying, let the developers continue to use LangChain or Llama Index, because those are the tools that they're familiar with, but make it possible for them to go and access these models through a managed infrastructure, right? Again, you'd appreciate, if you're young and you're working kind of on your desktop, it's easy to make a call onto the internet. If you're in a corporate environment or a larger network, you probably have some gateways, you maybe have Zscaler or some other network edge protection devices. And so you probably want to take that through a kind of central infra. But at the same time, you need to support the deployment of new models coming in. And that needs to be done in a very regularized manner, because otherwise everybody's just going to throw you their piece of source code or their piece of Python code and expect you to run that centrally, and that's going to break very quickly. Talking about some of these, and I'll give you a quick demo, about 5 minutes of kind of deep dive. This is fairly new. There's some components which are emerging. This is Light LLM, and it's not an LLM. Sorry, it's it's kind of an LLM gateway. What's interesting is that it's emerging very much into a space where I guess everybody's needs are, but it's not big enough to really make it commercial. It is open source. Luckily, it's got some great features, and I'll show you what it does. But principally, you're now in a position to start managing who has access to what, how much they've consumed, how many tokens, what is the cost. You can set budgets, you can set thresholds. We can do content inspection before we take the data onto the public LLM. So quite a lot of actually very neat features. Separately, I'll just talk about Bento ML. It's a very cool kind of open source initiative to wrap models into containers, align them to an international standard so that you can deploy them across different platforms. And it's all command line based, right? So you can very easily take kind of a model that you've written either using your own, let's say, classifier, or even language models and package them. So if I drill down into that, it supports a very wide range of models. And so the native ability here is just to draw on what is on Hugging Faces or Microsoft or other model sources, bring them in, build them, make sure the thing works. Of course, you can run them, which we'll demo in a moment, but then also deploy them through a kind of managed pipeline into a production environment. And that brings me on to Ray. And so Ray is a model serving platform, and there are, I think, just a handful of them. Again, you need something that can do this at scale and then manage the clusters, manage the resources, manage the scheduling. And so Ray Serve more specifically does this, is one of its components. And the nice thing here is it doesn't really care about what type of model you're running. It kind of gives you the observability and the mechanics to look into what's actually happening behind the scenes. It's not down to the data level, so it doesn't perform an auditing or logging function, but it really just looks at the overall operations of your kind of model serving infrastructure. So again, if you think of a business, anybody who's building systems around that, what you can now do is effectively create a centralized function that does model serving to the entire organization, right? You don't have to put models into every single business application and deploy them locally, and you have GPUs, other resources distributed across the org. You kind of end up with something that is centralized and can provide that probably in a better, more scalable manner than if it is federated and distributed. Okay, who wants to see a demo? Okay, only these guys. The rest, okay, I'll let you stay. But this might break. Let's see how this goes. Okay, hello. Okay, so let's have a look. I've scripted this to make sure that we don't fall over. But I like demos because it makes it a bit more real. So first of all, Bento ML, just a kind of front end in allowing me to interact with my containers. What I can do is I can do my models list. And so I can manage effectively all the models that I've compiled here, and I've put them in. So what you can see is I've got some underlying machine learning models or other, for instance, in this case, transformers that I've pulled in. And I've already put these together and compiled them. And so what I can do is I can now say I want to run this model. Let's say in this case a classifier. And what will happen is Bento ML will take that Python code. Maybe I should have showed you guys what it looks like. Maybe I'll do that afterwards. And actually brings it up and serves it to me. So in this case, I did not have to go and write in any HTTP handlers, any fast API or any front end. It just Bento kind of wraps that straight off the bit of Python code and gives me that front end. So if I show you here what that looks like, we can go, sorry, that's this one. Let me take that one. So what we've got here is the classifier is now running. It's running on a port 3000. And we can go to the different perhaps methods that exist in here. But you can see it's added in other methods around health checks and so on. So the nice thing about Bento is it simply takes care of all of that. I can start serving the model and consuming it as an API. If I put in some data here and I execute that, just to make sure I'm not cheating anybody, the result is 0. And if I put it through my classifier model, okay, the result is 2. I didn't hard code that value, just to be clear. So we now have a response from the Bento model, and we can see the requests being served in the background, right? Now, what I can do now that I've built this, I can simply take that same model. If I shut this down, and let me just see where I go. Oops, okay, that's probably not correct. And I can serve this. So if you look at kind of how I packaged that for Ray, what I've simply done is I've said, well, there's a Bento model, it's containerized, it's built already, and now I'm going to run it and deploy it onto a Ray cluster. the Ray cluster can already be running, right? So if you've got a big cluster, 20 machines, GPUs, all that, I can simply take my piece of code and push my model and say run it on that destination. And it's actually pretty straightforward because I just run this nice command, observe it, and fingers crossed, it'll power up my, my Ray cluster and deploy the bento container with the model inside. Okay, so what does that look like? Hopefully this loads. Check. So again, think of internal infrastructure within a corporate, right? Now I've got my bento running here. I can see the job. I can see certain information around within it. And as I said, it's got all sorts of logging and details here. So if we wanted to see the requests come through, I can probably just go into my bento as it is running here. And you see that log is empty. But nonetheless, I didn't have to worry about anything other than run a few commands, and my machine learning model is now in production and exposed. So again, now you can see that the port has actually changed to 8,000. Maybe also important to note is the container is not running, so that bento is not running as a container, but it is within my Docker, right? So my classifier is here, but it's not running within Docker. It's actually running within Ray and being served. So if I go to my prediction service, oops, that was it. So you can see if I go to that and access it through Ray now, I'll get the same endpoint. But again, just to make sure it actually works, I can put some data through that model and I get a response. But I can now also see that the requests are coming in into my Ray. So that takes care of the foundations. Now, taking that forward and, oops, being a bit too fast here, I'll bring in the proxy. So what I'm going to show you now is this light LLM. I've just configured it. Kind of nice, because in here, you might not want to take screenshots of my access keys, but nonetheless, it's kind of a configuration in YAML that allows me then to hide all the keys that my enterprise uses, right? So my enterprise has one subscription to OpenAI, one subscription to Hugging Faces. I don't want to give those keys to everybody in the bank, right? I'm going to have a big problem, and then next I'll have like 5,000 consumers accessing this from home. Instead, I put the keys into the YAML, I run it in the back end, and now it's connected. And let me just see, how do I access this? So now I've got my light LLM up and running, which is the front end. So think of like an Nginx to some extent. Oops, yep, that can happen. I know why. Localhost. Think of like an Nginx or like a reverse proxy, HA proxy, but more intelligent. And it's got a whole bunch of APIs, which I'm not going to bore you with. But if I go here to the admin panel, admin top secret, okay. We can now see effectively what's happening within my managed API gateway, right? So here, for instance, different entitlement. If I don't want Thorsten to have access to a certain model, I can remove it or add it. So there's different capabilities for managing models. I can test the API if I want to, set up different teams, but more importantly, I can look at usage, and I can now take that usage over a period of time and send that finance department like a $1,000 bill, and I can have that per day and whatnot. Sorry, I just touched this the first time a few days ago, so it seems to work. I'm quite glad. Okay, and so we can see where the consumption is coming from, and it does all sorts of verification. So if we look at perhaps what a request might look like, if I take it through my proxy, if you guys are familiar with Python, it's Python. I love-hate relationship. Okay, so here's a piece of code just to make a call, but as you can see, I'm not pointing it to OpenAI, I'm pointing it into my local host where I'm running the proxy, and then obviously I just wanted to write a short haiku. So if I run this, this is called proxy request. Oops, I'm in the wrong path. Let me just do like that. Okay, it'll now proxy that. You'll see the request go out, and we got a nice poem. Code flows freely, the open source river, knowledge share with all. Beautiful. And you can see the requests go through the proxy here. So what that means is I can also do things like this, which is important, because now if I'm a company and I don't want people abusing my prompt, if somebody takes a message in like ignore previous instruction, it'll actually get filtered out before it even gets to any of the models behind the scenes. So getting to the punchline, we've also talked about embeddings, right? We briefly talked about embeddings earlier. I think embeddings is obviously turning a string into vectors, right? So this is what it looks like. It looks a bit confusing because this is now put through a model, and the model has mapped these values, and it's really just a few string, this short string here, into these floats. And in order to make use of that now, I can see. I need to just change my dependency, otherwise it will not work. And I'll show you a quick demo of, for instance, me now inserting a kind of database of, in this case, wine. I think, oh no, what happened there? Is that, I'm in the wrong folder, hold on. That's the trick. Okay, so I'm going to import a database of wines into a vector database. What's actually happening is it is taking this text, it has put it through an embedding model, and it has then inserted it into a Weavient container. I'm a big fan of Weavient. If you haven't checked it out, you should. And in this case, it's actually taken the embedding instructions through my light LLM gateway. So again, what I've done is I've been able to create a vector database, stores all my data, but in order to do the embeddings, it'll talk to my local LLM gateway, and then it'll go out into the models, and those models can be served either publicly, like OpenAI, or those can be served internally. So why is this important? Why is this fun? Because now we can look at that embedded data. So you saw that it was kind of processed through my, my vectors. And I can now go to my Weavient front end. It's actually a very cool front end. I'm going to try something just to show you what it looks like. Weavient dashboard. Let me just go here. Okay. So what you can do is you can literally use this web-hosted front end to connect to your local host. So this is a container running locally. And what I've got here is I've got a GraphQL query directly onto my vector database, right? So the nice thing is I can, for instance, say, pull me out all reviews out of the vector database, and there we go. Or if I'm going to do a search now using, for instance, I would like to find some wines that taste like green fruit. I am now retrieving those out of the vector database, but again, to make clear, right, just to show you what that looks like, is that these results are being retrieved through my embeddings API, which is running within my own environment. So back to that demonstration is in that quick rundown and going through these different type of technologies, we kind of had that set up. We had the vector database interface with the AI gateway. That arrow is not on the diagram. We had the models and like the classifier being hosted internally on Ray. And we also had calls out in public cloud. And so I hopefully, I kind of hopefully want to leave you with this kind of curiosity around what this looks like at enterprise scale, if this is something that you can use in your own environments, and of course to think about all these non-model related concepts around things like billing, observability, role-based access control, token consumption tracking, vector databases, because all of these things are critically important. And unless you, especially maybe a younger audience, doesn't spend time on this, you're going to struggle putting systems into production, because doing things client-side is easy, doing things at enterprise scale is quite difficult. Thank you.
Yeah, let's thank the speaker. Yes, thanks for the very interesting talk. I guess we have a lot of questions, but not much time. So please, questions?
Thank you for your sharing. So I have, at SE, do you hide or buy some GPT model from OpenAI? And
So, okay. It's still very difficult for financial institutions to use OpenAI. There is, of course, the option to go through Azure, which has GPT as a model. That is possible, but there's a big concern about cost. So instead, we are doing two things. We're looking at just hosting open source models. I think I would advise, though, that the risk is that those models aren't truly open source by definition, because we don't know what training data went into them, so there's some other challenges around that. But what we're also exploring is just training our own models. So literally taking like 10 years worth of legislation, 10 years worth of regulation, circulars, and train your own model. Thank you.
Thanks. Further questions? Yes?
Thanks. Very I'm on evaluation of found model from generative AI, that is from AWS, and I have on the combination between LLM and retrieval. Yes. How great is the accuracy retrieval done by solution?
Okay, if I caught that right, to play it back, how accuracy is the retrieval of data when using large language models? Okay. So first off, if you rely on the large language model itself, you are of course susceptible to hallucinations and kind of very vague answers. So maybe first off, the power of large language models and kind of our observation is not in the language model. I mean, they're great, they're fantastic, but the power is actually in the RAG, and hence the vector database. Your vector database is incredibly important. Your vector database without metadata is like a big soup. You're not going to get anything accurate. So you need metadata. In order to make the metadata relevant, you probably need a graph in order to point documents to each other, right? It could be a graph of NLP, it could be a graph on document names or some sort of relationships. The advantage is if you're using RAG and using large language models on RAG, you get rid of the hallucination, right? Because the processing is always done on the source data. If there's anything that engineers should spend time on, and you can talk to me afterwards about this, is to the earlier point about models being built on garbage in, garbage out, is you got to make sure you get the right data together. Most companies still struggle with getting the data together, right? So data lake, maybe Databricks, some sort of data store. But the other side of it is you need to get your data input right, because very often you give it too little information or not enough information, you're also going to go wrong. So I don't think it's so much the accuracy of hallucinations. I think that problem can be mitigated, so you do not have hallucinations in the responses. But getting the queries right and to match on the right kind of data is tricky. That is, I think, where most of the engineering time will be spent. Thank you.
Okay, thanks everyone. Sorry, I understand that this probably, we could discuss here for another hour, but we have a next talk coming up. I'm very sorry. Please ask Thorsten, he's around here indirectly. He's for sure happy to answer any further questions. But let us please thank the speaker, Thorsten, again for his very interesting talk.
For waiting. I'm Wen Hao, a software engineer from OpenAtom, openEuler community. My previous speaker said that maybe it is a little difficult to use ChatGPT or other product in OpenAI here. So I come to introduce some other LLM to maybe have the same effect as ChatGPT. Okay, let's start. In the next 25 minutes or so, we will first to have an insight into the integration of AI and OS technology. As you know, openEuler is US, so we just research on that AI technology to integrate with the OS technology. And then I will introduce you the our Euler Copilot. Euler Copilot with two parts. The first part is we have released Q&A online service, and then we will introduce you that we proposed 1 + 1 + n intelligent architecture. And at the last, I will introduce some our release note to you. Okay. First, we are stepping into the intelligent era. Reflecting on the historical process, the three major industrial revolutions have propelled human society into the steam engine era, and the electro era, and the internet era. With each revolution reshaped our lives and the world deeply. And now we are into the fourth industrial revolution here. The AI industrial revolution will change our lives maybe more deeply. It will change our interaction with phone, with our laptop, or with our car, or maybe so on. Other things we will use and face every day. From the development of the AI with integration of OS, first with the popularity of ChatGPT, obviously, that let many people that maybe without technical skills start to focus on AI. And then Microsoft released his Copilot 365 that needs AI technology to start into our daily maybe office tools. And then Microsoft released the Windows Copilot. Windows Copilot is just overtaking the OS interaction. Maybe use the sidebar to interact, just replace the UI interaction before. And the Ansible Night Speed released. So the Watson X AI for programming, and it can generate the Ansible script that maybe affect our maintenance and maybe the operation of our engineering work. At the last, the Kubernetes GPT maybe replace our engineer, the infrastructure engineer, to analyze the complex Kubernetes task and arrange the complex tasks and maybe execute our query to handle the Kubernetes. Okay, now let me introduce you the Euler Copilot, the Q&A service. At the diagram on the left, we can see that our Q&A service consists of three parts. The first is the web and the framework and the model invocation layer. We have implemented our local open source models. Maybe you can be available like at the Hugging Face. And we also implemented that the third party commercial API, just like ChatGPT or other the commercial models released by many other companies. So why we should release the Q&A service for our openEuler community? Because openEuler community is just a community established for just 4 years. So the first thing encountered in front of us is to let users to understand what is openEuler and their features, maybe the community size, the latest news from our community. So
we think about the Q&A online service is just a perfect to match these needs. So we released the Q&A service. And our Q&A service is just is not just like the ChatGPT to provide the general question and answering service. We just mainly targets on 5 aspects that list on the right of the screen. It is general OS knowledge and openEuler, professional knowledge, and openEuler, extended knowledge, application cases, and shell command generation. We will offer RPM package to our users that you can install it on your server, and then you can use the shell command and maybe use your local language, semantic language, to type what do you want to do to replace the previous the shell code. So we provide the shell command generation at the 5th. Okay, so the reason why our Q&A service is a real-time AI assistance, because we constructed a data embedding pipeline. Here you can see load our local documents or extract data from the web, online web, and then split the documents into chunks and embedding them into our our DB. And the DB is not the only role to play here. It is also provides the ability to answer users' query, the search query. First, when our user's query is coming, our Euler Copilot will use the user's query to embed into embedding data. And from the embedding data, we will do keyword search and vector search in the unstructured documents and vector DB. And then we will use a re-ranker model to get the maybe the most related document chunk to our Euler Copilot and construct the prompt to our AI model. And the AI model will generate the query-related answer to our user here. And maybe it is not enough to perform a perfect Q&A server for our users. So we are still exploring to use the graphic DB, graphic circle, and the relational DB to aid to the search. So what the graphic circle can, the usage here is that maybe the user wants to know the relationship in our community organization. Maybe the user will ask, who is the commitment members in your community? So the vector DB cannot solve this problem. So we use the graphic DB. And maybe the user will ask, how many kernels have you released in your OS community? So the graphic DB and vector DB cannot solve this problem. So we use the relational DB to do some statistic work here. So we are still exploring it and will release it later. We are the best Q&A accuracy in openEuler domain. We adopted many tests here that used the open source large language model here. From our test results, that without our Euler Copilot, just use the LLM to answer users' question, the accuracy is almost the 35% here. maybe even if you use the ChatGPT-4, the accuracy will not exceed 14.5% here. But our goal is to have the 19%. So we plan to use the SFT to leverage by 10% of accuracy here. And use RAG, I introduced before. We want to leverage 14.5% accuracy rates here. So we will not use the fine-tuning, the SFT, to let the large model to learn more languages here. We only use the RAG to learn language. So what should we do to use the SFT here? We want the large language model to learn how to extract the available, the valuable information from the document chunk we provided to it. And then all of our knowledge just located in the RAG, our corpus DB. Up to now, we have uploaded 100K segments related to openEuler to our RAG here. And from our internal test, our current accuracy is above 16%. It still have some space to evaluate here. So, okay. Our Euler Copilot is not just a Q&A server here. We also want to help our business partners to bridging the tech gap from 2C to 2B, because our partners all have their own business. So maybe their demanding of customer and the business company is different here. For our 2C scenario, users often want to get text generation or image generation, maybe video. As you know, OpenAI released the Sora model last month, right? So maybe the video generation from our large language model. Moreover, maybe they want to use the Office tool to improve the usage of their daily work. There has a statistic that in Excel, the Office, Microsoft Office, before a skilled user of Excel can only use the 15 percent of features in Excel. But with the AI, the user, maybe the user without skill, that can use 85% of the features in Excel. And for our partners, for example, the telecom and financial, if there is just a dialogue books or just a tool that cannot satisfy their demands. So we summarized there has 3 paradigms shift for our business partners, from allotted data to allotted interfaces, and from mouse-oriented GUI interaction to natural language domain interaction, and from function-oriented API to semantic APIs here. We have an insight of some open source, the AI agents projects. Let the AutoGPT to be an example. As we know, the AutoGPT needs the GPT-4 ability here. So maybe many of our partners do not have the access to GPT-4. So maybe there has some limitation. So I summarized there has 3 limits for the AutoGPT. First, it requires the capability of the GPT-4. And the second, I list on the screen, that it still requires our users to do some coding here. You must to realize your request use the code, but many partners, maybe they don't have the development skill. So the third, the community activity has dwindled with the latest release dating back to December 2023. So as you know, we are OS community. So we plan to use the declarative registry in OS to integrate the data knowledge, the transaction API and the function API into our registry, and our Euler Copilot can load it. Then if RPM installed in our OS, the user can use our Q&A service to ask their question about the RPM. Not just like before that we type command, maybe ++ help. And then they can use the semantic query to ask the maybe application to do the things they want here. Okay, here is a full-stack solution based on 1+1+N. Let me explain what is 1+1+N. The first one represents our framework, and the second one is a semantic interface specification. The specification should be openAPI syntax compatible, because as you know, our traditional server, there has just like Swagger. The Swagger can export the openAPI very easily. So there has no barrier. Our user, maybe our developer, can transfer the traditional service into our AI application. And the last N represents to all of the ISV apps that want to maybe integrate it into our agent resource pool. Okay. Here is a demo representation for our Euler Copilot to apply for the dashboard. As you can see, I entered a query and I extract the data from the maybe local database or local server. And then I ask him to draw a chart for me. And it quickly responds for me. And one-click link, we can just link the sidebar, and from my own dashboard, you can see it is the chart just here. And I can manage the dashboard in my own way. Just refresh, and it is here. And most importantly is that if I want to change the condition here, it will not use the AI computing resource anymore. As we know, the AI resource is very, very valuable. So we cannot use the AI computing resource everywhere. So the chart will record its calling workflow here. It will record its working flow himself. So if I change the condition, it will return to our the real-time data very soon. Okay, our journey here is not end. It's just the beginning. In our 24.03 release, we will release the intelligent and Q&A server here. Just welcome all of you to visit our official openEuler official website, or maybe follow our official account to explain it. And then the new features I just mentioned, that the intelligent shell, intelligent operation and maintenance, intelligent turning, openEuler version expert, and just so on, maybe release successfully. And we welcome all of you that has an interest in AI application. May join us. We are just managed to create openEuler intelligent SIG, and you can just sing the CLA and participate into the Euler Copilot contribution. Okay. At the last, I want to conclude my topic with a picture that generated by AI. It is the Amazon forest. Amazon forest is the largest forest of the world. Millions of creatures just live in here. It's just like our openEuler community. All of you is just like a tree, a river, maybe a bird here. So we can just help each other, work together to make the community to be a fertile land. Okay, let's work together to make openEuler OS to be the second choice of the world. Thank you.
Yes, thanks to the speaker. Any questions? Yes.
Thank you for the sharing. I have a question about the real-time AI assistant structure. And can you share the technical you used to rerun the search results?
The re-ranker, right?
Yes.
Re-ranker is just a model, just like the embedding model. You can also get it from the Hugging Face. And the data embedding pipeline is just continuously to running here. It will collect the real-time data into our DB. Maybe the news just happened in the morning. You can ask our Q&A server maybe at the noon or in the afternoon. You can get the news. But if you use a pre-trained large model, it cannot done the task. Okay.
Thanks for your answer. And I have another question. I have some problem about input queries. Have some words not exist in document.
Most of documents here, right? So
yes.
you want to ask how to embed in the lot
yes.
of documents into the DB?
There are some words not in query user and not in document, but it's the same mean.
So you want to ask the DB just play the data pipeline rule and also play the user query rule here, right?
I mean, there are some words. Some words in use query have same meaning. Some words in document, and when I search, the search result is not good because two words in
understand.
meaning. Yeah.
Understand. Use the embedding method is just a low-cost method here. If you do not have enough AI computing resource, I suggest you to use this method to get the data from your Q&A server. Okay.
Okay. Further questions? Yes.
Is there any hardware recommendation? Are there other copilots used in the server, or can it used in the embedded device?
Hardware.
Hardware recommendation.
We are exploring to use maybe the small size large language model to running on CPU chip here. We are exploring maybe less than 10B, the large model language, and use our customization. We want to get the same effect as maybe the model that is 17B size here. So with customization, maybe later we can use let our users to run just the whole Euler Copilot server on his CPU. We don't need that he to buy the expensive GPU here. Yeah, we are just exploring. We are just researching here. Okay, please keep focus on our official. Okay, thank you.
Any last short question from the audience? Well then, let's thank the speaker again.
Thank you.